2, 3. Can you guys hear me and see my video? Yes? Okay, good. I'm so sorry for the technical glitch. Okay, so yeah, let's resume the file. Okay, so now I will begin by introducing our first keynote speaker. She is Associate Professor Dr. Noornizan Muhammad Azahan from the Faculty of Food Science and Technology, Universiti Putra Malaysia. Dr. Noornizan received her bachelor's and master's degree in Food Science and Technology from UTM and her PhD from Cornell University. She is a distinguished food technologist and a recipient of prestigious Yarka Regional Professorial Chair in 2025-2026. Dr. Noornizan has served as a Deputy Dean at FSTM and also was on the Executive Committee of Non-Thermal Processing Division of IFT. Specializing in non-thermal food processing, her research addresses food security challenges by leveraging processing technologies like high-pressure processing, UVC, pulse light, ultrasound, PEF, and irradiation. Her work also integrates non-thermal processing with clean label product innovation and sustainable waste reduction. Currently, her focus is on establishing a robust ecosystem for the HPP industry in Malaysia. She also plays a role in TVET empowerment as an M-Board curriculum evaluator. So let's join me to welcome Dr. Noornizan to present her topic on moving high-pressure processing from standalone innovation to systematic food infrastructure. Dr. Noornizan, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Dr. Hawa, for the introduction. Before I begin, I would like to thank the organizer for having me as one of the speakers to speak on HPP. I'll be sharing my slides now. Can you see the slide, Dr. Hawa?
Yes, I can. You can turn it into this presentation mode. Yeah, that's good.
Okay, all right. Thank you. So, yes, it's my pleasure to speak about HPP, and our focus today will be on moving high HPP from standalone to systematic food infrastructure. So this is the scope that I'll be covering. I won't be covering about basics of HPP because I assume most of the food science students would already know what HPP is and what it does. But I'll be talking about the overview of the HPP industry, where it's now and where it's moving toward. Okay, and before we get to that, I'd like to introduce a little bit about non-thermal processing technologies. Here is 6 of the many non-thermal technologies, and just like any siblings in a family, each technology would have its own strength and weaknesses, and it's got its own history. For example, irradiation is one of the oldest, and I call it the big brother. And then we have high pressure processing, which is the favorite among all of these technologies because it's very versatile and is the one that is most successful in the commercial world. Then we have UV light. It's a light technology that's very gentle, so we call it the gentle baby because it only decontaminates surfaces of food items. There's issue with penetration power and issue with shadowing effect. And then we have PEF, or the pulse electric fields. I call this the fighter because PEF existed, it comes about around the same time as HPP, but HPP made it through and becomes very successful while PEF is still lagging behind. It's only about 7-8 years ago that PEF started to become more commercial in the industrial world, especially for fried potatoes. And then we have pulse light, which is almost similar to UV light, but is more effective as it has 3 different spectrums to it. And the penetration power or the killing power is stronger than UV light alone. The UV light is the UVC type, the germicidal type of light. And then lastly, we have supercritical CO2. I call this the independent because among the non-thermal siblings, supercritical CO2 always keep to himself. It doesn't mix around much because it's very independent. It can be by himself and be successful out there. So that's basically about some of the non-thermal technologies and under the big umbrella non-thermal processing. There are many other technologies which I'm not highlighting here, such as ozone or blue light and also cold plasma. Now, let's get back to HPP. From this map, we can tell that HPP is being used in many parts around the world. So it's not an unknown technology, it's already known, especially in the North and South of America, Europe, East Asia, as well as Oceania. And on the right side of the slide, we can see a list of top HPP brands which are very successful. And among these top brands, Hyperbaric leads the way with 60% of the market. And why is Hyperbaric so successful compared to the other companies? Because they are very good at translating the science. I'm not trying to promote Hyperbaric, but let's learn from them. In Hyperbaric, most of the employees have at least master's degree or PhD holders. So they are really a company that is being backed with solid science. And they understand the physics of HPP, and they were able to manufacture the equipment according to what the industry needs. And looking at the numbers, Hyperbaric has more than 400 units of industrial scale HPP, which other companies at the moment cannot match this success. So we know that HPP is a preservation tool which could extend shelf life of products like juices and also meat products. If we look at this chicken salad, so it's a wet salad without preservatives, without acidifiers and additives. After 10 days of refrigeration, the microbial count, the cold-loving bacteria, is just less than 10 for HPP item, while for the control, there's 17 million cold-loving bacteria after 10 days. So you can see clearly the effect of HPP in this case is very significant. And here is example of how HPP affects microbial cells by causing cell lysis, and this is for Listeria and also E. coli. Not just preservation, HPP could also recapture value of certain food items. This meat, for example, if we look at the dark cutter here, this is the type of meat that is darker than the other meat because it comes from the darker side of the animal body. So it's biology. It doesn't mean it's bad quality meat, but it's just dark in nature. So this is the meat that is always left on counters in the supermarket unsold. People are not buying it because they thought it's meat that has turned bad, but actually no, it's just the original color is like that. So what University of Nebraska-Lincoln did to help this butcher is that they HPP treat the slab of meat with different pressures, 300, 450, and also 600 megapascal. And it's very obvious that the 300 megapascal pressure give a very good color, almost similar to other types of meat, which is not the dark cutter. And when they measure the T-bars values, it's also lower than the other pressure levels. So 300 megapascal for 3 minutes seems good to recapture the value of this meat product. Not just meat, but fruits and vegetables could have the advantage of HPP too, especially the ugly ones that doesn't fit in with the normal grading system or standards that imports or exports have set. So these are still nutritious, highly nutritious with good color. It's just that it's deformed or doesn't look appealing to people. So we have to convert this into juices or purees and sell it in the bottle or packet and treat it with HPP. The value is still premium, but we just need to change the way it looks. For food items that are high in flavonoids or phenolic compounds, without HPP, we get a certain value, but with HPP, we could enhance that value because HPP is a great tool for extraction. It allows more and more of these compounds to get away from the plant cells and to be free. And when you analyze it, you get it. You get the data, you capture the value of these items. So it adds up value while preserving the product. Okay, I cannot speak about HPP without talking about clean label. So maybe some of you haven't heard of this term, but clean label is a movement by the consumers. It's not a movement by the industry. So consumers are demanding that processed food items try to eliminate as much as possible additives or preservatives and try to be as natural as possible, not just being clean with a label. They are also demanding transparency. Where did the raw material come from? Is it from a GM product? Is it from plant? Is it from animal? Does the meat item comes from a farm that practices good animal welfare? They want to see all of this in the food label. So a long list of ingredients is not good to the eyes of the consumers who embrace the clean label movement. So this is potato salad with egg, and those with red colored fonts are additives that's added to preserve this product. So when we use HPP and we add in the element of clean label, we could reduce the number of ingredients in the product and still extend the life of this item. And it's almost 1/3 of the original list. So this is a clean label HPP product. Another example would be sausages. We know that sausages are high in salt content, so HPP could do the job of reducing the when we reduce the amount of salt in the formula, HPP could help retain the saltiness level, meaning with reduced amount of salt, HPP will help homogenize the emulsion in the sausage and allows the consumer to taste the reduced salt as if it's the same like the original formula. So that in a way will get us to produce a product that's healthier than before. Another example is chili paste. This is chili bo that we all have in our kitchen. So we did a short research on this. It was actually a final year research and undergraduate research. Yeah, we found that when chili bo samples were collected, 9 out of 10 samples bulldozed the regulations, meaning they exceeded the permitted levels that our Food Act allow For example, the sodium benzoate content and colorant was excessive. So when we tried HPPing this chili bowl, what happened was the color was enhanced, chef life was improved, and the pungency or the capsaicin taste, the spiciness of the chili was also enhanced. The color was really bright red color, as if we have put some colorants in it, but we did not do that. Okay, so this is part of HPP and clean label. HPP is also a solution provider, problem solver to some of the food items that we cannot, that has enzyme issues, and we cannot overcome it using thermal treatment because the texture would change, the color would change, and some of the good nutrients will be lost. A classic example would be avocado or alpukat. Yeah, avocado would turn brown very, very quickly after cutting. So this is because of enzyme activity, and by using HPP, not just we inactivate the enzymes in avocado, we also enhance the color to bright green color and extend the life of these avocado products. Photo on the upper right hand of the slide is showing jackfruit straw. We were trying to make mandai out of it. So mandai is a traditional Banja food, and it tastes like chicken. So this is vegetarian, but when you fry it, it tastes like chicken. So we tried to ferment and HPP treat this straw so that it lasts longer up till the point where we want to use the product. Another example is durian paste. Durian will only fall when it's fully ripened, and that also means that it's very, very perishable, highly perishable. So it also has some enzyme issues. It gets spoiled easily, so HPP is the way to go. The same as coconut water and also watermelon juice. We cannot heat treat this kind of beverages, so HPP provides the solution to extend the life of this coconut water and watermelon juice up till 90 days of storage in the refrigerator. So that is helping the farmers extend the income throughout the year, especially during the rainy season. So it's obvious that HPP has several benefits: food safety, extending life of at least 3 times longer than the original state, and also an ally to clean label. But there are two other advantages of HPP. One is cross-border trade advantage, where most people who exports HPP products said that when you're exporting to Europe, Japan, Korea, it makes it easier when the authorities see in your flow chart that you have HPP as one of the processes. Some exporters said it cuts down quarantine time. Some said it just makes the process a lot smoother, because countries like Japan, Korea, and Europe are very strict about food safety, and they recognize HPP as a tool that helps with food safety. Premium positioning is very synonym to HPP because we know the nutrients are still there, it's safe, and normally people who work with HPP choose their raw materials well. So they start off with premium, highly well-selected raw materials, and also after HPPing, they're selling the product to a targeted market. So this is crucial, yeah, very important that when you have a HPP product, you ask yourself, who am I selling this product to? Because if you sell it to the right group of people, people who are willing to buy the product, then it's a success story. Okay, now, whether HPP is compatible with halal or not, yes, definitely, because the medium that we use to provide pressure is water, and water could be recirculated for the next cycle. Food is not directly in contact with this water that we use as the medium, because food items going into the HPP equipment is already packed, and no chemical additives, because this is a clean label partner. So it jives well with the concept of toyib and not having any harmful things in the food item. And like I said, food items are pre-packed, so there's no issue of cross-contamination because we have the packaging material as the barrier to eliminate risk. So when it comes to business, there are two formats to HPP. One is the simplest format, just like UPM. Customers send their packed samples to UPM, and UPM offers tolling services. So we HPP treat the product of already packed food item, HPP it, and send it back to the client so that they could distribute the products. That's the first model. The second model is companies buy their own HPP machines and have in-house production and also offer tolling services to others. But if this is the option that businesses are choosing, then they have to do their homework. Number one, they must ask the question, from whom am I buying this equipment from? From which company, which brand of HPP machine or equipment? Because it does matter. Some brands are reliable, some brands offer very good after-sales service. So this is critical, yeah, after-sales service, especially when you're trying to get spare parts for maintenance. Because if the after-sales service is not good, then it's difficult to get the spare parts and get the help of technicians in case there are some troubleshooting that needs to be done. Another homework that this second model will need to do is to figure out the proper pressure and temperature to use, or whether the product or such a process has already been validated elsewhere. Then the final thing that they have to check is whether the manufacturer has the right documents, the right certifications for safety. Meaning, if they want to install in country X, whether the authorities of country X would approve all the configurations, all the safety features of the equipment, because there have been cases of many companies offering, saying that they could fabricate the HPP equipment, but the question to ask them is, how many equipments have they installed and where did they install this equipment? Because if we want to install in Malaysia, you have to ask, have they installed any in Malaysia and how many have they installed? Because if they have sold so many equipments but installed none, then there's a question to ask there whether the safety features are good or not. Because if our OSH or NIOSH doesn't approve, even if you buy it from a good company, but if our OSH doesn't approve, you cannot install the machine in Malaysia. Okay, so that are two models for HPP business format. So certifications and validation studies must be clear before you run this according to this model. So we already know the science, what HPP could do. We also know commercially HPP works. And this is the unit that we have in UPM. Unfortunately, this type of equipment is currently a batch type. So it's a standalone, like an island business. So your clients come from elsewhere, you offer tolling services, and then off they go. What the industry is doing now is actually moving to another phase of the technology. And I would like to use the example of the halal industry as a model. Halal industry in the 80s is all about no pork, no lard, no alcohol, and slaughtering the right way according to Sharia. That was in the 80s. But as we move to the 90s, they are looking at other things as well, such as where did the raw materials come from? Does the suppliers have do the suppliers have halal certificate or not? How about the thickeners? How about some the colorant or flavoring agents? Is it halal? Is it not? How about the oil or the grease that you use on the conveyor belt? Is it food grade? Is it halal? Is it a risk to the halal industry? But as they move towards the year 2000 onwards, there are more things that they are looking at. They are asking the questions whether the animals were raised or were reared in a farm that practiced good animal welfare. Pre-slaughtering activities, was there any good animal welfare, or was the animal stressed before slaughtering? And then they were having all the different analytical methods that's assisting the auditors. And then they are also including halal logistics into the whole halal infrastructure. So it's the same like HPP from tolling service only. Now HPP is heading towards tolling services plus cold chain logistics. So it's an integrated business or process. And they are also looking at making HPP, instead of a batch process, becomes a continuous line. So how people are doing that, we'll talk about it in a few slides to come. But before that, I'd like to share about the Langkawi case. These guys, these 5 individuals are good friends, and they are from the Langkawi oyster farm. During the pandemic, COVID-19, they lost their jobs and they started breeding oysters in Langkawi. And they learned from USM about breeding oysters that's sustainable, because if you breed only oysters in the area, then you would enhance algal bloom. So they know how to breed oysters and make the ecosystem more balanced by breeding other things around it. So that prevents the formation of algal bloom. So they know, they have the knowledge about breeding oysters and have produced a lot of oysters. And in Langkawi, one of the Langkawi identity oysters is the rock oysters. It's called the rock oysters. And they were trying to sell it to the 5-star hotels in Langkawi, but the hotels did not want to take it because they were afraid. They said, we worry about food safety. How do you ensure that your product is safe for consumption? We don't want any food poisoning issues. So they are importing oysters for the hotel, which is a shame because Langkawi have their own oysters. So what these boys did, they came to UPM and tried so many things with the HPP. They tried shrimps, they tried it with lobsters, oysters, and other types of shell seafood items. Yeah. So we got very positive results from this. This is the rock oyster after HPP. So it's really easy to take the meat out from the shells because the shells are already open. Yeah, so it's not shut shells, it's already open shells. Okay, so easy to get it out from the shells. They also worked on mussels, and this is HPP treated mussels already wide open. And we found by accident that the muddy coat on the shells yang macam lumpur is gone after HPP, because without HPP, no matter how hard you try to wash it, the muddy coat will always come back. So HPP does the trick. So if one is trying to sell mussels together with the shells, then HPP is the way to go. And not only that, there's one thing that comes with the mussel. This part is the fibrous part on the right side is detached from the shells after HPP. So this is the part that we don't eat, that we need to remove. And it's quite difficult to remove, but using HPP, HPP does the job. Now let's compare the shucking productivity between HPP shucking and also manual shucking. One of the boys, Langkawi Oyster boys, is a professional shucker, and we asked this person, to shuck oyster within a minute. So he could do between 2 to 3 oysters per minute, but using the HPP, depending on how large or how small the HPP equipment is, like ours is small for industrial scale, it could do around 160 to 200 oysters per minute, okay, compared to 2 to 3 per minute. And in terms of meat size, the HPP treated ones are larger than original size, because the oyster liquor, the air oyster, yeah, gets into the meat after HPP. So it becomes more flavorful, like an explosive, in your mouth, it will be explosive with the oyster liquor. So it's very juicy on the inside. And in terms of yield, you get 100% yield clean from the shells. There's no leftovers compared to manual shucking. And at the same time, HPP helps eliminate the pathogens. Okay, now for the Langkawi case, if they want to come to UPM from the jetty, they need to take the ferry, and that takes about 30 kilometers, burning CO2 of about 16 kilograms. So that's the CO2 emission of taking the ferry, and then on land, they have to travel 465 kilometers to get to UPM with 88.82 kilograms of CO2 being emitted. So that brings it to a total of 105 for a one-way trip just to get to a HPP equipment from Langkawi. Okay, so what is 105 CO2 footprint? This is equivalent to charging your mobile phones every day for 35 years. And that is a one-way trip. Okay, so you can see it's not good to have HPP far from your production site. If HPP could be closer to your production site, that helps lessen the carbon footprint, and it also helps extend the life or stop deterioration of food items or contamination of food items earlier in the stage. Questions to ask: does every company need its own HPP equipment? No, you can use a tolling service. Do we need more tolling facilities? Definitely yes. How would more facilities help lower cost? This is, like I said, by reducing the carbon footprint, as well as having deterioration stop at an earlier stage so you can have a longer life for your food item and reduce waste. What other initiatives could be introduced? Basically, the solution is to have HPP as available and accessible as possible. So this is about geographic reach. To get a good geographic reach, we need to increase the number of HPP in the country, having a good HPP network. When there's many HPP in the network, it also helps with maintenance issues, because if you need a spare part and it takes time to get from your supplier, then the other member in the HPP network could assist that. It's happening right now between HPP companies that is in Klang Valley. So in terms of configuration, there are two types of configuration. Number one is the standalone configuration, the impact configuration. And under the impact, you have the standalone configuration, just like what UPM has. Another type is integration ready. For example, you have robotic arms together in the production, and then it goes to the HPP machine. So robotic arms help you do the job faster to load and unload packed materials from the HPP machine. And another example is combining the packaging line together with the HPP machine, which has been done by Multivac. And the third configuration in impact configuration is to combine HPP with thermal treatment. And this has been done by Cyro Australia, where they are trying to get HPP to do sterilization job. So without the help of thermal treatment, spores cannot be inactivated. You cannot sterilize food items using HPP. Okay, number one and number two are both pasteurization. So preheating food items to a certain temperature, getting it into the HPP, and leveraging on adiabatic effect of pressure to get to a higher temperature level within a few minutes, only a few minutes, very short time, to get to sterilization. So this is relatively new, but it's getting there into the industry. Then we have the bulk configuration. This is for extra large, super large industry, where you HPP treat the juices, and then only bottling line will come into picture. So bottling is done after HPP to allow the use of glass jars or glass bottles instead of plastic bottles to address sustainability issue. So the juice will be in a big jumbo bag like this, and then HPP treat, and then will be pumped to the outlet tank and into the aseptic chambers for bottling. It must be done in the aseptic condition after HPP and during bottling. So again, we know the science of HPP. Now it's translated on site, because instead of an island process, now we have an integrated process with other utilities, and instead of batch, it is now starting to become a continuous type of process. So with the help of robotic arms like this, it can make the process faster for improved productivity, because a 3-minute HPP process or a 5-minute HPP process is very short, and to load and unload will take more than that. So this helps in a way to make HPP a more productive kind of process. So when strategizing from land to label, physical connectivity is important, and I've mentioned this in the previous slides. We have to reduce the food miles by processing at the source. The processing facility must be within the same zone as a raw material. So it must be close to the farmers. And it will be good for Malaysia because Malaysia is not a big country. If I'm talking about Peninsular Malaysia, but for Sabah Sarawak, it's huge. So 150-kilometer radius may not suit Sabah Sarawak, but for Peninsula, 150 kilometers is not that far to reach a HPP facility. Meaning, if you go from KL to Malacca, for example, it's not that far. It's reachable, and it could help accelerate the time to market. For Sabah and Sarawak, with all the logistics issue, we have to think of another approach of how we can get HPP within reach to the farmers. Okay, an example from China. In Xinjiang province, they have this apple called the red heart apple. So the red heart apple, the flesh is very red, so the liquid or the juice is red in color, just like the color of a red heart. And normally only farmers eat this apple. Other people do not know this apple because it is seasonal, and only near the farms you can find this apple. Okay, so one entrepreneur tried to HPP treat the juice of this apple and extend the life of it so that it's still available when the fruits are not in season. And it started to become viral because now the public knows how the fruit tastes like, and it's got a local identity to that province. And from November 2023 to April 2024, the sales surged by 400%. This is April is just before the season ends. So people are starting to buy so that they keep a stock of all these juices because it tastes so good and it's nutritionally dense. So by sharing with you about this story of this red heart apple, what I'm trying to emphasize is the focus on raw material selection. Okay, because HPP in the end you will sell it as a premium product, so raw material must be carefully selected. Digital connectivity is another aid that will help with strategizing from land to label. And one example is real-time monitoring. So whenever there's maintenance issues or troubleshooting issues, technicians from the supplying or manufacturing company could assist the on-site technicians. This is very
Dr. Nora, you
Yes.
have 3 minutes left.
Okay, I'll try to speed up. Okay, thank you. And then the AI-based maintenance is also important for productive maintenance rather than doing preventive maintenance. In terms of energy input, yes, it's using electrical energy, but it's also sustainable because we are recycling the water and reducing waste of food items, and the high energy input is being offset by all the good benefits of HPP. So we get a total system value. Another thing that is needed is shifting the mindset from asking about cost per production cycle. Instead, we need to ask about yield. What is the cost per cycle mile and cost per shelf life day? How much mileage can you gain when you HPP your product, and how much more extended life can you gain? And the goal is to lower the CPC and increase the yield. This is example of how lowering CPC and increasing yield would be useful. Okay, the green one is when you increase the yield and lower the CPC. So all you need to do is increase the capacity of production and also have a more number of HPP network. This is an example of how logistics and HPP jives together. Coconut water from Thailand being exported to the US, but before exporting, they concentrate the coconut water using forward osmosis to 23-degree bricks to reduce cost for logistics. And when it reaches the destination, it will be reconstituted and HPP treated. So it works well with logistics. So having all the logistics in place, the farm to logistics must be in the category of same zone or same geographical area closer to the farmers and SMEs. By having the extended life, it allows HPP producers or HPP product owners to select whether they want to use air or sea or ground transportation. So logistics is now integrated in HPP services, and we can see from this example of Hyperbaric partnering with Sunrise Logistics, and in Thailand, they're also doing the same, providing cold rooms and also transports with temperature control, as well as China and Thailand partnership. This is tea processing from raw material selection. They really select the raw material 2-3 times of screening the material before they cold brew the tea using HPP. So HPP could do the cold brewing effect. Another thing which this company, they just bought Quintus this January, is to look at the marketplace. They are using digital commerce or e-commerce to sell their products. Remember, I told you that the target market is very important. So basically, from batch island, now we move to the systematic infrastructure. It's changing. Then it was production to label, now land to label, and then in the future, it will be land to shelf. So from the 2 models, now it has become 3 models with emphasis on raw material selection on the farm and also certification by the High Pressure Council. Ongoing effect in Malaysia is that we are working with the authorities to establish guidelines and standards, training the auditors and officers in KKM, and validation center is in the pipeline, not quite there yet. We're developing entrepreneurs and new talents and developing a robust ecosystem for the industry. A take-home message is that HPP is a known technology which has matured and moved from simple operation to infrastructure. Raw material is key, market identification is crucial, and partnerships are important. So for the undergraduates, I have a call for action for you to pay attention to. Please be part of the ecosystem and be an activist for useful technologies no matter where you are in the food industry. Understand clean label demands and try to build a good ecosystem. Don't just ask if a company employs HPP, but ask how they are integrating it into the supply chain. Before I end, I would like to invite all of you to join us at the 4th IFRC in Bangi in August. So there's still time for abstract submission if you haven't done so. And you can also attend workshops before the conference. We have 8 workshops altogether, and you can scan the QR code and you can take a screenshot of this slide. That is all from me. Thank you very much.
Okay, thank you so much, Dr. Noranizan, for sharing your presentation. I hope you can see me in the video or not really.
I can see you.
Okay, that's great. Yeah, very interesting presentation. It's really interesting to understand that HPP is the now technology to improve food safety, extend the shelf life, offer clean label as well as halal. So now I will invite the participants for question to our keynote speaker. You may turn on your microphone or you can post your question in the chat box. Is there any question from the participants? Let me check the chat box. So while waiting, it's really interesting when you mention about the sterilization um, process integrating with the HPP, where especially to inactivate the spores, right? Because when you heat the food first, and then basically you kind of heat shock the spores to induce germination, and then use the HPP to do the rest of the work. That's very interesting. Maybe one question from me. So for all of the work that you've done with several food matrices, which of maybe food category that you think are very challenging to being subjected to HPP treatment? Like for example, like high protein, is there any challenges on that, or high fat and so on?
Thank you, Dr. Hawa. Yes, protein is challenging because protein degradation happens at higher pressures. So you need to use lower pressures. But I think the industry has now figured out how to deal with proteins and HPP because a lot of nutraceutical companies are using HPP to pasteurize their product or to modify their product. We have, for example, colostrum susu awal that's being processed in little bottles for babies who did not get colostrum. Or we have protein shakes, meat shakes actually, in the form of beverages or pea protein. But I think technologies have figured out a way on how to deal with that. Another example is high carb but low moisture food items. HPP doesn't like low moisture food items, but when people are processing ready to eat meals, sometimes a lot of things are high carb and low moisture. So there are issues with the starches in the system that makes the food not appealing enough, but it's only a quality issue. It's not a safety issue.
Very interesting. Participant, is there any question from the floors, or you can post it in the chat box? Anyone? Okay. I guess another question from me is that when you mention all the processes to make HPP become a mainstream technology, from your opinion, in Malaysia particularly, how many years do you think, like you anticipate that it will become like a go-to for most of the food manufacturers?
Actually, in Malaysia, we are not at the infancy stage anymore when it comes to HPP. We have passed that phase, and it's getting more and more matured, and we have a lot of success story. So this will convince entrepreneur, and I think the impact will be seen in less than 10 years from now. But to get to where we are now, it took almost 25 years.
Wow.
Yeah.
Okay, last call. Any question from the floors or in the chat box? Okay, so if there's no more question, thank you so much, Dr. Arnizan. I would like to express my gratitude for your amazing keynote presentation. And that concludes our first keynote session. Thank you so much again.
Thank you.
Okay. So everyone, before we continue, a kind reminder to all attendees who joining this conference today to please register to the second day of FOSTUC via link provided in the chat box. So we would be very appreciate if you can do that now, okay? Okay, so now it's time for our second keynote speakers. He is the Honorable Professor Technologist, Dr. Muhammad Fazli Abu Bakar from the Faculty of Applied Sciences and Technology, Universiti Tun Hussein, Malaysia. Prof. Fazli is an expert in functional foods, nutraceuticals, herbal science, and phytochemistry, a PhD in biomedical sciences from the University of Nottingham, biochemistry, and a bachelor in nutrition and community health from UPM. His academic credential has led to his excellent research track records, which mainly involve the discovery, characterization, and mechanistic evaluation of bioactive compounds that mostly geared toward the prevention and management of non-communicable diseases such as obesity, gout, cancer, and skin-related disorders. Prof. Fazli has led numerous national and international research grants, including FRGS, industrial grants, innovation-driven funding, and ASEAN-India collaborative projects. He has held key academic leadership roles, including Deputy Dean, Research Development and Publications, and Head of Research Center, and currently serves as Principal Researcher of the Advanced Herbal and Ethnomedical Research, or AdHerb, at UTHM. He is also a registered nutritionist under the Malaysian Allied Health Profession Council. Last but not least, his work has received multiple national and international awards for research excellence and innovation. Without delay, Prof. Fazli will present us a topic on Bambangan, Mangifera Pajang, and underutilized fruit of Borneo, recent development as functional food and nutraceutical. Prof. Fazli, the floor is yours.
Thank you, Dr. Nurul Hawa, for the introduction. So let me share my slide first.
Okay, I can see now.
All right. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everyone. Selamat berpuasa, selamat menyambut Ramadan kepada semua. First of all, thank you to the organizing committee of the 4th Food Science and Technology Undergraduate Colloquium 2026 for this honor. It is a privilege to be here with all undergraduate students, food scientists, and also innovators. Today, I would like to highlight something close to our regional biodiversity, yet scientifically underexplored. I'm not sure whether you ever heard about Bambangan or Mangifera Pajang. This fruit is indigenous, native to Borneo, traditionally consumed. It remains largely underutilized in the context of functional food and nutraceutical development. In food science, we no longer see food as a source of calorie, but now we analyze it is a matrix of bioactive compound. For example, in the fruits, a source of polyphenols, carotenoid, dietary fiber, and also antioxidant molecules that may show physiological benefits beyond basic nutrition. In this talk, I will briefly discuss the relevance of the fruits in food innovation, scientific progress on Mangifera Pajang, and also prospect the fruit as a functional ingredient and also as a nutraceutical candidate. So, I think Mr. Chairperson already introduced a little bit about me, but I will, before we continue, I will allow me to briefly introduce myself again. So my name is Muhammad Fazli from Faculty of Applied Sciences and Technology, UTHM. I am a professional technologist and also registered nutritionist under MOH. My academic training spans from food technology, nutritional biochemistry, and also biomedical sciences with my PhD from the University of Nottingham, UK. My research focuses on functional food, bioactive compound, nutraceutical development, especially exploring on the underutilized tropical resources and also scientific finding into value-added application. So the topic I'm sharing today actually reflects what I have been done for the last 10 to 15 years, which is actually connecting biodiversity with food science and also innovation. So let us begin with the fundamental question. What is a fruit? So from botanical perspective, fruits are developed from the flower or ovary of a plant and represent the edible seed-bearing structure. So it is a primary biological function is seed dispersal, which is ensuring plant survival and also propagation. However, we as a food science perspective, fruits are far more beyond that. The complex biological matrix, for example, the fruits contain water, carbohydrate, organic acid, fiber, and vitamins, minerals, and importantly, phytochemicals such as polyphenol and also carotenoid. So globally, fruits serve as an essential dietary component and significantly contribute to the antioxidant intake and also overall nutritional quality. So, while botanical simple in definition, nutritionally and biochemically, fruits are highly sophisticated system. And this brings us to the important point lah. So, if fruits are such a rich source of active compound, what about those that remain underutilized, such as bambangan? So, globally, the demand for tropical fruits continues to rise at a significant rate. Firstly, from the slide, we can see that the increasing production volume are driven by the expanding market and also stronger international trade. Tropical fruits are no longer consumed only within the producing regions. They are now globally commodities. Secondly, consumer behavior has shifted. Today, consumers are health driven. They seek or they search for fruits that are not only taste, but for scientifically supported health benefits, particularly antioxidant capacity, anti-inflammatory potential, and also metabolic health support. Third but not least, developing nations dominate tropical fruit production. In fact, they account for nearly all tropical fruit output and also important proportion of global supply. This create an important opportunity. Southeast Asia, this Asia Tenggara lah, is globally recognized for its extraordinary fruit biodiversity. We are familiar with commercial dominant fruits lah. Contoh kalau di market kan, kita familiar dengan tropical fruit. For example, ada mango, ada durian, rambutan, betik, pisang dan sebagainya. Many of which have successfully penetrated international market. However, beyond these mainstream products, there is much larger and less explored diversity. Brunei, for example, alone is estimated to have about 200 species of edible fruits, yet the majority of these species remain underutilized and poorly commercialized. Macam di Borneo lah contohnya, kan dia ada banyak tumbuh-tumbuhan, tetapi tumbuh-tumbuhan ni kita kata tidak digunakan sepenuhnya dan tidak dikomersialkan sepenuhnya. Despite documented nutritional and phytochemical potential. We are biodiversity rich, Malaysia, yet are value poor in terms of functional ingredient development. For food scientists, this gap is not a limitation. This is actually an opportunity for us. So underutilized fruits are untapped reservoir for bioactive compounds, novel flavors, and also functional properties. And bambangan is one of those promising candidates emerging from this biodiversity landscape. Okay. So the question then becomes, if biodiversity is abundant, why these fruits still underutilized? First of all, many of these species grow naturally in the forest and rural area, far from structured commercial supply chain. Without integration into agriculture system, scalability become a major constraint. Second, there is a limited promotion and also low consumer awareness beyond local communities. Contohnya buah-buahan ni, dia found locally or abundantly in Sabah and Sarawak, for example, but in Peninsular Malaysia, some fruits is very rare and also uncommon. So without branding and scientific validation, this fruit remain regionally confined. Third, planting area are minimally and also largely small scale. Dia jarang lah yang ada besar-besaran. So there is no organized cultivation model to ensure consistent yield and also quality standardization. Finally, and perhaps most critically, there is insufficient research and development. So we as a food scientists, this is our part. So despite promising nutritional and economical potential, many species lack scientific documentation to support commercialization. Okay, to understand the potential of underutilized fruits, we can look at a successful predicent. For example, the Amazon. Several indigenous fruits from the Amazon rainforest were once locally consumed and unknown outside their region. However, nowadays, through scientific validation and strategic commercialization, they achieve global superfruit status. For example, saya rasa pelajar-pelajar mungkin pernah tengoklah buah-buahan ni, dia popular dekat Amazon dan sekarang dia popular dekat mainstream dan juga negara-negara lain. For example, acai berry become recognized for its antioxidant capacity. Second, kita ada kamu-kamu. This gain attention as a natural source of vitamin C. Last but not least, ahuahe is become valued for its beta-carotene richness. Before this, these fruits only dominant in Amazon, but nowadays I think most of us know, for example, acai berry. So these fruits were not new discoveries. What changes was research, documentation, branding, and also market positioning. This demonstrates a critical lesson. Unutilized fruits can transition into high-value functional ingredient when supported by strong scientific evidence and also product innovation. So this question for us in Southeast Asia is clear. If this Amazon can do it, why not us? So could Bambangan be one of our equivalent? So before we focus especially on Bambangan, it's important to understand its geographical context. Borneo is the third largest island in world, shared by, tahu kan, kalau Borneo Island ni dia ada shared by Malaysia, Indonesia and also Brunei. Kalau Malaysia ni Sabah, Sarawak, Brunei and also Indonesia, Kalimantan. It is globally recognized as one of the richest biodiversity hotspot on Earth. Okay, next. Okay, before any laboratory analysis begin, scientific work must start in the field. Extensive survey, different region of Borneo have documented a diversity of indigenous fruit species. These field trips of field exploration are crucial, not only for species identification, but also for understanding seasonal availability or morphological variation and traditional uses. Through systematic sampling and documentation, selected fruits and then prioritized based on criteria such as edibility, abundance, local consumption pattern, and also potential functional value. Kalau kita tengok di dalam slide ni, ada fruits ni, I think in Peninsular Malaysia, the fruits is rare, but in Sabah and Sarawak, the fruits is very common. For example, we have macam bawah sekali kanan tu kita ada macam buah cempedak, what we call it in Sabah, we call it tarap. Atas sekali belah kiri tu kita panggil di Semenanjung saya tak pasti, tapi kalau di Sabah kita panggil pengalaban lah. Lepas tu di bawah sekali belah kiri tu that one is macam keluarga mangosteen, tapi nama-namanya lain lah, kita panggil asam aur-aur. Di Sarawak, di Sabah Sarawak juga ada durian merah, which is I don't think we have the in Peninsular Malaysia, dan juga yang lain-lain lah. Okay, now we turn our attention to Menjifera Pajang, or commonly known as Bambangan. It is an indigenous mango species native to Borneo and highly valued within local communities. Unlike conventional mango, Bambangan has a thicker peel distinctive aroma, and a more complex flavor profile, often consumed fresh, fermented, or also pickled. Traditionally, it has been appreciated for its culinary and cultural significance. However, from a scientific standpoint, it represents much more important component. Preliminary study indicate that bambangan contain high level of phenolic compound, dietary fiber, and also antioxidant component. So this shift our perspective. Bambangan is no longer just a traditional fruits. It become a candidate for functional food development and also nutraceutical exploration. So what is bambangan? So scientifically known as Menjifera pajang, consterman, belief originate from Borneo Island, spanning from Sabah and Sarawak, Brunei, and also Kalimantan. Okay, next. So the kingdom is Plantae, the order is Pindalis, and the species is Menjifera pajang, consterman. Local name in Sabah is Bambangan, but in Sarawak and Brunei, the name they have different name. So example Mawang, Embang, Membangan. And also in Kalimantan, the fruits are also called as limun, asam pangan, or pangit. Okay, next is the flesh. Next. Okay, the flesh comprises of 50 to 65% of total fruit weight and also characterized by bright yellow color, sweet, sour, juicy taste. Tapi dia berlainan sikit lah dia punya in term of dia punya texture. Dia lebih fibrous texture lah. Kalau kita makan mangga biasa tu, dia lebih smooth dan lebih licin. Kalau bambangan ni biasanya dia characterized by fibrous lah. Dia banyak serat-serat yang sometimes tak boleh ditelan. You makan dan you kena luahkan balik. Lepas tu dia ada distinctive aromatic turpentine mango-like aroma. This is the fruit morphology. The whole fruit left, kalau sekali pandang tu macam buah ciku lah. Tapi sebenarnya dia adalah keluarga mangga. Kalau belah kanan tu adalah cross section of Menjifera pajang, revealing the thick peel, golden flesh, and also the large central kernel. Okay, in important dimension, we must consider its conservation status. So according to IUCN Red List, Menjifera pajang is classified as vulnerable. So this indicates that the species faces a high risk of decline in the wild if current environmental pressure continues. The primary threats include deforestation, habitat fragmentation, and also land use changes across Borneo. This introduces a wild perspective. When we talk about developing bambangan as functional food and nutraceutical resources, we are not merely discussing commercialization. We are also discussing about the sustainable utilization. In other words, responsible innovation can align with biodiversity preservation. Okay, next is the historical cultivation and also usage. So, bambangan grow naturally in the wild, but also have been traditionally cultivated by local community in Borneo, particularly among the Dayak and Kadazan Dusun group. It has long been integrated into local diet, consumed fresh, fermented, pickle lah, dia buat jeruk, bambangan, or processed into traditional dishes. In terms of composition, the flesh account of 50 to 60% of total fruit weight, and is the primary edible portion. So, however, the peel and kernel, which together may constitute to 35 to 40% of the fruits, are typically discarded. Biasalah kalau kita makan mangga pun, bijinya dan juga kulitnya biasa kita akan buang. For a food science perspective, this is significant. This byproduct may contain valuable active component, representing an opportunity for waste valorization and also functional ingredient development. So, for the traditional culinary application, bambangan play an important role as a local culinary practices. The flesh is commonly eaten fresh or processed into pickle. It's naturally sour and aromatic profile makes it particularly suitable for savory dishes. It often cooked with fish, chicken, or meat, contributing a distinctive mango-like acidity that enhance the taste of the dish. In certain regions such as Sarawak, even the young leaf are blanched and consumed as vegetable, sometimes paired with chili paste or fermented product. Okay, next we look at the nutritional composition. From the nutritional standpoint, the proximal composition of Mencifera Pajang reveal interesting feature. The fruit contain moderate carbohydrate level, contributing to energy value alongside with dia ada juga lah amount of protein dan juga fat. But more importantly, Bambangan has a high total dietary fiber content compared to common mango variety. Both insoluble and soluble fiber fraction are present, which are relevant for gastrointestinal health, glycemic modulation, and also overall metabolic benefits. So this elevated fiber profile may partly explain its potential functional relevance. The key vitamins in Bambangan is vitamin A or beta carotene. Based on research, the content is approximately 2 times higher than common mango. And the vitamin C content is comparable to common mango, play vital roles in immune function, collagen synthesis, and also antioxidant defense system. Next is the phytochemical constituent. Research on Bambangan phytochemical has accelerated recent years. Ini ada orang lain buat research lah in 1994, Wong and Seo. So 50 volatile components were identified in the Bambangan essential oil. Mostly on monoterpene hydrocarbon, mostly on alpha pinene and also alpha palindrene. Okay, this research, this is actually part of my work before this. Moving beyond the proximate composition, this phytochemical profile of Bambangan, if we can see this published finding in food chemistry, demonstrate that different parts of fruit have different level of active compound. From here, we can see that the kernel contain phenolic content up to 20 times higher than the flesh. So this is a very critical observation. So the kernel which is typically discarded, biasa kita buang kan kernel ni, tapi kandungan fenolnya dia 20 kali lebih tinggi daripada isi dia. So this kernel actually represent a concentrated source of phenolic and flavonoid. So this shift our perspective from waste to resource. Instead of viewing the peel and kernel as processing residue, they may serve as a high-value functional ingredient. So further phytochemical analysis revealed that Bambangan kernel contain diverse spectrum of polyphenolic compound. Kalau tengok dalam ni, dia ada macam-macam lah. Phenolic acid, dia ada caffeic acid, coumarin acid, ferulic acid, cyanopic acid, dan also galic acid. Dia ada juga flavonoids, naringin, hesperidin, and also etc. lah. Ada flavonols dan juga flavones. Okay, next for the beta carotenoid found in Bambangan peel and also pulp, dia ada trans alpha beta carotene, cis beta carotene, 9 cis beta carotene, also cryptozanthine. The work that we did from the grant that we received is the anti-cancer potential of Bambangan. Okay, next, we look at when we study on the antioxidant potential, for the investigation, we evaluated the biological activity of Bambangan extract using in vitro model. So this paper by me and also my colleague, we published in Food and Chemical Toxicology, examine the cytotoxic and also anti-proliferative effect of different fruit part against several human cancer cell line. Interestingly, the peel and kernel extract demonstrate measurable inhibitory effect in certain cell model, whereas the flesh showed minimal activity lah. However, it is important to emphasize that these findings are based on in vitro assay sahaja. They indicate that potential bioactivity, but they do not translate directly to clinical efficacy. Sebelum ni ada yang keliru lah. So this is just kajian praklinikal ataupun in vitro sahaja. So what this tells us is that Bambangan contain bioactive component capable of influencing cellular mechanism under controlled laboratory condition. Okay. Next, this research conducted by Prof. Aspullah, phytochemical investigation lead to the isolation of multiple bioactive compound from Mencifera Pajang. This include phenolic derivative such as methyl gallate, megiferonic acid, as well as related compounds such as In addition, several triterpenes and phytosterol have been identified, including lupiol, beta-sitosterol, stigmasterol, and also related derivative. Next, we look at the cytotoxic activity of bambangan. This slide summarizes the cytotoxic data of bambangan extract and isolated compound against several human cancer cell line, including breast, HeLa, and also colon cancer. Among the different extract, ethyl acetate and methanol fraction demonstrate comparatively stronger inhibitory effect. Certain isolated compounds such as megeferonic acid, the specific triterpenes also showed measurable activity in cell-based assay lah. However, it is crucial to interpret this finding correctly. This activity value reflects cytotoxic effect under controlled laboratory condition. They indicate bioactivity at the cellular level, not at clinical or also efficacy in human. So this is the cell cycle in cancer research. So next. So the slide highlight the effect of methyl gallate isolated from bambangan kernel on cell cycle progression. As you can see here, at 24 hours, we observe a shift in cell population distribution, increase in the sub-G1, which is commonly associated with apoptosis lah. So, selepas 72 jam, kita incubate extract bambangan dengan sel, the effect become more pronounced with further accumulation in sub-G1 and also alteration in genoid G1 and also G2M phase. This suggests what we conclude from this slide is that methyl gallate induce cell cycle arrest and promote programmed cell death under in vitro condition. So these findings support the earlier anti-proliferative data and provide mechanistic insight beyond basic simple cytotoxic. Okay, next we look at the time course morphological changes. This slide represents flow cytometry data illustrating time-dependent morphological changes in cancer cell treated with bambangan kernel extract. What we can conclude from this presentation, from this slide, at 0 hours, the cell display normal morphology. Semua normal lah dari dekat kuadrat bawah kiri itu. So, selepas 48 jam, we begin to observe early cellular stress response. Maksudnya dalam ni adalah membrane acceleration, shift in cell population distribution indicating onset of apoptosis ataupun cell death. Selepas 72 jam, this effect become more pronounced with significant increase in apoptotic cell population and clear morphological degradation. Okay, so next we look at the apoptosis. So apoptosis refer to programmed cell death. It's a regulated biological process that allow the body to remove damaged or abnormal cell in controlled manner. So kalau kita nak cari ubat untuk anti-cancer, kita punya extract tu dia induce apoptosis. Kita tak nak sel tu induce necrosis lah. Sebab dia necrosis dia akan induce inflammation dan sebagainya. So kalau kita ada extract, kita nakkan extract tu bagus, dia kena induce apoptosis, yang mana dia akan remove damage or abnormal cell in a controlled manner. So next, we look at this slide, summarize the time course analysis of apoptosis induction following treatment with bambangan kernel extract. So, kalau kita tengok at 12 hours, early apoptotic marker begin to appear, indicating initiation of programmed cell death. So, I just jump to the 72 hours. Kalau kat belah bawah kanan tu, late apoptosis, secondary necrosis become more evidence. Tapi sikit je. Dia mostly late apoptosis, consistent with prolonged cellular stress and also certain bacterial exposure. So this progressive pattern reinforce an important conclusion. The effect is time dependent and biologically regulated rather than immediate non-specific toxic response. Okay, next we look at the possible mechanism. What we can see here, ini kita study on caspase activation lah. So secara ringkasnya, caspases is a proteolytic enzyme that play central role in programmed cell death. They function in the cascade manner. They initiate caspases activation, downstream execute caspases. So in this study, the activity of initiated caspases such as 2, 3, and 8, and 2, 8, and 9 was evaluated along with execute caspases including 3 and 6. So kita tengok activation of caspase 9 associated with mitochondrial pathway triggered by cytochrome C release. Lepas tu dia ada activation of caspase 3, directly responsible for DNA fragmentation, also cellular dismantling. So for student or for postgraduate students, this is the for drug discovery. So the process of developing pharmaceutical compound is highly structured and rigorous. Dia ada banyak flow lah. So it begin with botanical authentication, phytochemical screening, followed by bioactive evaluation, toxicity assessment and also mechanistic study. So ada banyak lagi cara, sebab tu biasanya kalau kita nak ada preclinical clinical study, dia makan masa 8 ke 12 tahun lah. So for us, food scientists, this highlight an exciting reality. An underutilized tropical fruit can serve as a starting point for functional ingredients, nutraceutical, and potentially future therapeutic leads when supported by rigorous science. Okay.
Prof, you have 5 minutes left.
All right. Okay, thank you. So this is the antioxidant of bambangan. So it's obvious that the kernel contains superior antioxidant as compared to peel and also flesh. Next, we can see that there is a cardioprotective effect of bambangan. Bambangan has also been evaluated in human-related functional studies. Daily consumption of bambangan juice increased plasma beta-carotene and ascorbic acid, increase the antioxidant status, and also reduce cardiovascular risk. So next is the dietary fiber in bambangan and bambangan product. So next is the bambangan peel. Tadi kita baca cerita pasal bambangan kernel. So bambangan peel ni dia contain soluble fiber, insoluble fiber and also dietary fiber. So from this, next we can see that from the fiber we can turn into confectionery such as bread, cookies, pasta, etc. So next, this is the research data summary. We can see that the peel nutritional functional value boleh buat high fiber, antioxidant dan sebagainya. For pulp boleh buat pickle, dehydrated dan sebagainya. Dan for kernel tu untuk nutraceutical. So next is the product of bambangan. Ini ada produk-produk lepas kita buat research ni like 10 years ago. So produk-produk yang ada sekarang ni dah ada macam-macam lah. So next we can see that one of the product yang ada di pasaran is bambangan juice. Bambangan juice use fruit natural high beta-carotene and vitamin C content. The bambangan juice powder drink has been studied before this. So they might have benefit to cardiovascular health, for example. So next we can see that the bambangan has been turned into jam. Next, bambangan also have been turned into mainstream consumer market. Its vibrant color, dia ada aroma dia, natural sweet sour. Profile make it suitable for frozen dessert applications such as bambangan ice cream. So next we can see that bambangan pickle ataupun jeruk bambangan, traditional condiment widely consumed among indigenous community in Borneo. It is made from fruit flesh combined with grated bambangan seed. Meaning that orang dulu dia dah guna dah kernel ataupun bambangan, dia punya seed tu dia incorporate dengan dia punya flesh, mix with salt and selected spices and make into bambangan kernel. That's mean dia dah consume the kernel before this. So next finally, bambangan represent more than a functional food. It represents sustainable agriculture model. The entire fruit can be utilized. The flesh for food product, the peel, high fiber functional ingredient, the kernel for bioactive extraction. So this whole fruit utilization approach minimize waste while maximizing economic value. Okay, next. Next, research team. I would like to thank late Prof. Dr. Asmar Rahmat from UPM, my supervisor, and also Dr. Jeffrey Fry, and also Pro Emeritus Dr. Mariti Muhammad as a principal investigator, co-investigator Dr. Yazan, Dr. Fazlin Izani, Dr. Aspula, Dr. Kartini, and Prof. Johnson, and also all my postgraduate students. So I would like to thank also UTHM for internal funding, contract grant, GPPL, GPP, ICI, and also IGSP, collaborating institution, UMS especially, my strong collaborator from UMS, from IBTP, FSMP, from Jabatan Pertanian Sabah, Teknik Magis Cepat, and also University of Nottingham, UK, and also at Undergraduate. This project is funded by Mosti eScience Fund, ERGS, and also FRGS. So before I end my presentation, next, I would like to talk a little bit about UTHM. Kalau ada yang tak pernah dengar atau tak tahu UTHM, UTHM adalah Universiti Putra Malaysia. It's one of Malaysia distinguished public university. Ada yang confused lah, ada yang ingat UTHM ni private university. This is a public university, previously known as Kuito. UTHM hold the unique distinction being the only public university named after a former Prime Minister of Malaysia atau recent on the third Prime Minister. So the Chancellor of UTHM is Yang Amat Mulia Tunku Ismail Ibni Sultan Ibrahim, Pemangku Sultan Johor, the Chancellor of UTHM. Next, the location of UTHM, mungkin ada yang tak pernah tahu, located in Johor. We have two campuses. The main campus is in Parit Raja. My campus, Fakulti Sains, Gunaan dan Teknologi, ada dekat Pagoh lah. Pagoh ni lebih dekat dengan Melaka dan juga dekat dengan Muar. So di fakulti main campus, kita ada postgraduate studies, mostly on engineering. There is civil engineering, electrical engineering, mechanical, management, technical dan TVET, dan juga science computer dan juga IT. Ini adalah among the facility that we have. We have the library, mosque, dewan dan sebagainya. Okay, the next is Pagoh campus. Kita ada 3 fakulti sahaja, Faculty of Applied Sciences. Ini adalah di mana kita ada program-program seperti kimia industri, food technology dan sebagainya. Ini di kampus UTHM, kampus Pagoh. Kita ada juga FTK, Fakulti Teknologi Keseraan, dan juga kita ada pusat pengajian diploma bagi lepasan SPM. So ini adalah wajah ataupun rupa UTHM kampus Pagoh. Next, kita tengok ini, dia agak taklah terlalu baru tapi kita start 2017 lah. Kita belum lagi jejak 10 tahun, ini tahun yang ke-9 kita beroperasi di UTHM Campus Pagoh. With that, saya ucapkan jutaan terima kasih kepada semua. For further information, mungkin bolehlah kontak saya atau email dekat fazli@uthm.edu.my. With that, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Fazli, for your insightful presentation. Okay, now I will invite the participants. If you have questions for our keynote speaker, you can ask directly by turning on your microphone, or you can post your question in the chat box. Any question from the floors?
Assalamualaikum, Prof. Thank you for your kind presentation. I'm Dr. Farid from UPM. Yeah.
Assalamualaikum warahmatullahi wabarakatuh.
Interesting to know about this Bambangan. It's something new for me lah. Pasal saya orang Ishmi. Anyway, I'm interested on one of the point. Well, my basic background is I left the area for about 24 years ago. So now I'm in the market area. So I'm interested on one of the point that you mentioned earlier. You said that Bambangan also into confectionery products. I saw you show the is it possible to replace all these? You know that the trend of healthy food, consuming the wheat, semua takut mati kan, pakai bread pun tak nak white bread. So is it possible that bread or loaf can be marketable in Malaysia or in the world? Maybe Subway can use it one day. What's your point of view? Thank you, Prof.
Thank you very much, Dr. Ahmad Farid from UPM. Very good question, Doctor. In terms of confectionery, we do have some research. We transform the Bambangan into confectionery. For example, we do have students doing Bambangan fruit leather, for example. So what they did is the puree of the bambangan, they mix with some sugar or honey, and then they dry it and they have like a leather. They want we can transform the bambangan as one of the product for the confectionery, for example. So second, probably maybe hard candy or lozenges. Apa yang kita pernah buat sebelum ni adalah yang ekstrak bambangan yang pekat tu kita masukkan peringkat akhir masa kita buat hard candy tu sebab kita nak minimumkan dia punya gradation of volatile component. So kita ada juga gunakan spray dry powder untuk stabilize the aroma so that the moisture content dalam moisture content tu less than 3% lah untuk elak dia punya stickiness. So kita ada juga buat coklat bambangan. Yang itu kita ada juga coklat kita incorporate as a filling untuk bambangan punya puree kita masukkan dalam coklat as a coklat bambangan. Selain itu kita ada juga student yang buat bambangan jus, bambangan gummy candy. Itu yang kita dapat this 3-4 years lah, tapi it's quite difficult for us to get the perfect condition for the gummy candy, but still we doing the R&D. So for example the gummy
Interesting, Prof.
candy,
Yes.
for example the gummy candy, we use for example pectin-based halal friendly alternative to the gelatin, and we use the bambangan sebab dia memang ada tinggi pektin semula jadi, so kita boleh optimizekan dia punya gel strength lah. So itu adalah produk-produk yang pernah kita ada, yang contoh confectionery yang kita boleh buat daripada produk-produk berasaskan bambangan, Doktor.
Okay.
How is the quality of the product, Prof?
Again, Doktor?
The
Consumer
stability of
perception
the
or
product.
acceptability of the
Okay.
that you mentioned.
Since the product is still mostly in R&D, and the fruits we don't have in Peninsula Malaysia, we have to bring it from Sabah and Sarawak. So most of the product is still in R&D. But in Sabah and Sarawak, I can see that, for example, ice cream bambangan, juice bambangan, jam bambangan pickle, that one is quite common. Being sell in store, di kampung-kampung, di pekan, di tamu, quite abundant. But it's Semenanjung, saya rasa macam tak pernah tengok kan. Dan most of the product is still in R&D. Kita hanya pasarkan mungkin masa kita buat food festival di peringkat UTHM, dan kita mostly lebih kepada food tasting lah macam tu. Sebab kalau kita nak buat produk-produk sebegini, kita memang kena pair dengan company yang untuk buat skala besar, dan kita kena dapat raw material yang lebih banyak untuk kita produce in large scale lah. Itu yang kita punya rintangan yang kita hadapi lah in term of commercialization of underutilized fruits.
Okay, Prof. Thank you so much for your comprehensive response to Dr. Farid's question. Okay, so there's another question in the chat box from Dr. Ahmad Hanif from UPM. So most food products undergo processing process like heating that degrade most heat-sensitive bioactive compounds. So how can we minimize the losses which ultimately enable us to produce high-quality functional food product with good efficacy?
Okay, thank you very much for the question. In food processing, it's quite difficult for us to retain or maintain some of the bioactive compound, especially compound yang tak tahan dengan haba, tak tahan dengan processing lah. For example, flavonoid, vitamins dan sebagainya. So kalau kita tengok, most of our research, we try when we do the drying, we try to use very low temperature. We try to minimize the temperature. We try to use freeze dry. But if you want to use oven, we will try to use very low temperature in order to dry our sample. So other than that, macam yang lecturer sebelum ni ada tunjuk daripada UPM, mungkin kita boleh gunakan teknologi seperti HPP, dan juga mungkin kita boleh encapsulate lah, guna spray dry, gunakan carrier untuk kita encapsulate the bioactive compound. So this kind of what I said is still within a lot of research, and at the moment I think a lot of our colleagues from UPM, from UMS, from Unimas, and also some university in Kalimantan and Brunei doing this kind of research in order to retain or maintain the bioactive component in our food product. But for example, if we do home base, it's quite difficult for us to retain the bioactive compound. But if we do the, for example, HPP, or we using high high quality processing, we might able to maintain or retain the bioactive compound.
Okay, thank you so much. There's another question from Sabrina, UTHM. I would like to know, how does Bambangan differ nutritionally from common mango varieties?
Okay, what I have mentioned before this, in terms of dietary fiber, they contain much more higher dietary fibers, insoluble fiber as compared to common mango. So for the rest, I think it's more comparable. But for beta carotene, the content is double from common mango. But for other vitamin, I think it's quite similar. So, but more or less, I think the nutritional content, the vitamin and mineral, more or less comparable or not comparable, higher as compared to normal mango.
Okay, thank you so much, Prof. Fadli, for your response. I'm sure you will be open for further question if there's any from the participants beyond this conference. Thank you so much. Thank you all for your question, and that concludes our second keynote session. Thank you so much, Prof. Fadli, for your amazing
Okay.
presentation.
Thank you, everyone. Thank you, Dr. Nurul.
Okay. Okay. Before we continue the fun, we are going for a 10-minute break. During this time, presenters and jury, please join your respective breakout rooms during this short break and get ready. So there's two ways to join the breakout room. First, if you see at the very bottom panel, you see the red cross, right? So next to it is a dot, the three dots, so you can click on it. Okay, you should find join breakout session. At the moment, it's not there yet, but it will be very soon. Another way to join is to open the participant panel. If you see the person icon there, you can click on it, and then you will see at the very top of the panel, there's a breakout session. So now it's starting. Okay. Breakout session. Okay, and if you wish to leave your breakout session, what you can do is you can click on the red box arrow and then click leave session, not leave meeting. Okay, if not, you're going to be out of the conference. Okay, so the last important reminder, we will share a feedback form at the end of this afternoon. We would be very glad if you can fill the form for our future improvement. So with that, enjoy the rest of the conference. I wish all presenters the best of luck, and I'll see you in the closing ceremony. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Dr. Awa.
Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to everyone. I'm Dr. Wan Sedatushida Wan Kamarudin from the Faculty of Applied Sciences, Universiti Teknologi MARA, UiTM Shah. Will be your moderator for today's session. It is my great pleasure to welcome all of you to the second day of the 4th Food Science and Technology Undergraduate Colloquium 2026, FOSTUC 2026. We are truly honored to have such a distinguished audience with us today, including our respected keynote speaker, researchers, lecturers, and students from participating universities. Your presence reflects the strong spirit of collaboration and academic excellence that FOSTUC represent. To continue our final session of FOSTUC 2026, it is my great honor to introduce our esteemed keynote speaker, Associate Professor Dr. Adimat Sikin, who will share valuable insights and set the stage for meaningful discussions today. Associate Professor Dr. Adimat Sikin is a senior lecturer at the Faculty of Applied Sciences, Universiti Teknologi MARA, UiTM Shah. Prior to joining academia, he gained valuable industry experience as a production and QA executive in the food industry. He holds a PhD in Food Science and Technology from Cornell University, United States of America. He previously served as the head of program for Food Science and Technology at UiTM Shah Alam, overseeing both undergraduate and postgraduate academic programs. He is currently an adjunct professor at Universitas Padjadjaran Indonesia, a life member of the Malaysian Institute of Food Technology, and also an associate member of Academy Professor Malaysia. To date, he has published 39 scientific articles and one book chapter in the areas of food safety and food processing. He is currently supervising 6 PhD students and 2 master students. In addition, he served as a trainer in food sensory at the International Food Safety Training Center. Dr. Adi has also been invited as speaker at Universitas Padjadjaran Indonesia and Government College University Lahore, Pakistan. He is also a chairperson for drafting the Malaysian National Standard for Beverages and Beverage Products and committee member for drafting food legislation and standard in Malaysia. Beyond academia, he actively shares his perspective on food-related issues in Malaysian newspapers. He is also passionate about cooking and painting. Without further ado, please join me in welcoming Associate Professor Dr. Adi Matsikin to deliver his keynote addresses entitled Technological Innovation for Food Security. The floor is yours, Dr. Adi.
Thank you, Dr. Wan, for very kind introductions. Okay, give me a second to just share my slide. All right, okay, can you hear me?
Yes, Doctor.
All right, okay. First and foremost, I would like to thank the third Food Science and Technology Undergraduate Colloquium for the invitation to speak for this webinar. So we may have listened from our fellow speakers, okay, who gave their expert insights on many different approaches to maintaining or enhancing food security. For example, Prof. Nora has discussed a lot about one of these emerging technology, HPP, as well as Prof. Muhammad Fazli, who actually looked into the underutilized fruits in Borneo, and also Prof. and also Prof. Khairul, who actually discussed on the native potential of the native mushrooms as food ingredients. So to complement to these discussions that we have today, I would like to present just an overview on technological innovation for food security, which also discuss the challenges that we may face in line with the theme of our colloquium, advancing food security through translational science, okay, which is not only maintaining food security, but also we'll be looking at the translational scientific approach in even enhancing food security. Right. Now, we are facing a very challenging time where food security has never been so important before. For example, the mass media in Malaysia has been discussing quite often than ever on solutions to overcome our dependency on food supply from import goods. So this is actually an article that I sent in early October 2020 urging the makers in our country to relook how secure our food supply and to look into localizing our food supply in response to restricted border policies during the COVID-19 pandemic. So among others, I propose that we should strengthen our local food supply chain in fruits and vegetables and to reduce the food waste at household level by relooking at the subsidies that have been given by the government so that we are more mindful with the food we waste when we no longer enjoy the reduced price of food items. So when I submit my opinions on to New Straits Times, to the newspaper, so it didn't actually take long for them to publish it. So this is actually to indicate how important the issue of food security in the time that we are facing right now. All right, so there are many factors contributing to the depletions of food resources or food supply globally. Okay, climate change, loss of farmland to biofuel or mining, pests and diseases, water stress, war and conflict, poverty, to just name a few. Okay, so, feeding the world sustainably is one of the greatest challenge in humankind. All right, and in fact, our food sectors contribute 30% of global greenhouses uh, emissions, as well as we use almost 70% of global fresh water. So considering these numbers, okay, so every one of us, especially in the food industry, should feel very responsible to find ways on how to actually look for a better approach in maintaining our food security. And in fact, there is one what we call that environmental, social, and governance, or we call it as ESG framework that is going to be implemented within the food industry probably in 10 or 15 times in the future, which actually put so much emphasis or put the check and balance mechanisms to the environment as well as the needs for the social, what we call that, awareness, as well as how we actually govern our business or our food businesses or our food supply chains in maintaining the in maintaining the food security. And for example, carbon footprinting, which is to measure the greenhouse gases, okay, the greenhouse gases, for example, carbon dioxide, methane, as well as nitrous oxide, okay, is measured, okay. The release of these greenhouse gases is measured in a product cycle, okay. Normally, the measurement is a kilogram carbon dioxide equivalent. So we want to see, for example, for 1 kilogram of product that we manufacture, how many gas emissions at each single step of production we produce, and then we will total. So the efficiency of our food production will have to be based, whether we like it or not, on this framework, which is ESG framework. So if we look at this slide, okay, from 1961 to 2000, okay, so there is an exponential increase in population, increase the demand for food by more than 100%. Although this demand was met, but it is at the expense of a healthy environment and abundant resources that we live in. So we have been putting more chemical to the soils to emit gases that give us back the greenhouse effect, and the list is continue. So in 2050, it is estimated that there will be 9.7 billion people on Earth, and we will require more, about 70% more food than we consume today. Now, so before I go further into many different technological inventions in maintaining or even enhancing food security, so let's look at the definition of food security. So what actually is food security? So food security is actually a multi-dimensional concept. Therefore, each and every one of us will be looking at food security problem based on our professional experience and training. And so often than not, we tend to specialize in addressing one aspect of the larger food security problems. Okay, so the problems like agricultural productions, trade, income, food quality, clean water and sanitation, governance, and political stability. These are all factors that influence our food security status. So in 1996, okay, World Food Summit, which was held in Rome, says that food security exists when all people at all times have physical and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preferences for an active and healthy life. Okay. So, reflecting to this definition, I would say that every research effort, okay, that a food scientist and all of you, the students, just presented in our breakout session just now, uh, thus all boils down to food security. So we are not saying that, okay, my study is very specific only to actually looking at, biofunctional of certain plant extract and stuff like that. So, but actually, every single study in the area of food science and technology would eventually contribute to the maintaining and enhancing food security. So it is basically a food security based research. So there are four main dimensions of food security. Okay, number one is availability, which addresses the food supply through food production, food stocks, food aid, and import capacity. Okay, number two is how can we get access to this food, which address the purchasing power, okay, we as a community. And number three is a food utilization, okay. This is an interesting concept for the fact that traditionally it is all about consuming sufficient protein and energy only, which is more to quantity than quality. And in fact, WHO and the US Committee on International Nutritional recommend an average of 2,100 kilocalorie per day per person. All right. So we what we call that we the how we actually utilize our food will only or has been only based on calorie intake per day, okay. But other factors also should be looked into, okay. that affect the food utilization. Okay, for example, the food. Uh, if we refer to the definition of the food security, okay, it is not only that giving you that energy, but also the food needs to be nutritious and also safe. Okay, so the last uh, of what we call that food security dimension is the stability. Okay, the stability is how we can actually secure and make sure that the availability of food, the access of food, and the food utilization will always be sustainable and maintained. Okay, which very much dependent on the weather variability, price fluctuation, political, and also economical environment. Now, um, if we put the rice supplies, our rice, Malaysia's rice supplies, within the context of food security, mentioning those four dimensions just now that I just mentioned previously, uh, if we are talking about the availability of rice supplies, okay, our national stock reserve will only last 4 to 6 months at any year, okay, and and in, and what makes things more worrying is that a lot of countries now are becoming more protective with their own rice supply. For example, India will ban exporting rice, which already started in July 2023. So that is if we consider about the rice supplies availability. And what about the accessibility? All right. Our government, Malaysian government has already what we call that very put the very strong mechanisms on the table which control the price of the rice and also subsidies also is given to the farmers in terms of fertilizers and technology as well as the consumers by controlling the rice price. So if we are talking about the utilization, there's not much to discuss except that our own what we call that palate only prefer the polished white rice, which contains a lot less fiber. Okay, so it's just supply you with the calorie and carbohydrate and nothing more than that. So the fortification of this rice should be a way to go. Okay, if you are talking about the utilization, which is one of the four elements of this food security. And the last one, stability and how we actually maintain these other availability, accessibility, as well as the utilization of this rice. So we have to actually look into many other different approaches. Okay, for example, instead of expanding the rice plantation, we should actually look into ways on how to increase the yield of the rice. All right. Precision agriculture is one of the technology that we should be looking into. Mechanization in the harvest of the rice. Okay. Also should be also looked into, and we cannot stop looking at new rice variety which can resist to the climate change. Okay, we should not put a stop. Okay, the effort of actually looking or coming up with a new variety of rice altogether to ensure that the food security is maintained. Now, so where are we in food security? Okay, to simplify the complexity of the factors that contribute to food security. So one tool which is called as a Global Food Security Index, in the acronym there too is GFSI, is used to assess a country in food security considering the 28 indicators within the 4 dimensions that I mentioned, which is affordability, availability, quality, safety, and many more across these 113 countries. So as you can see here, among the ASEAN countries, Singapore is a small country, but is in the top rank, which is followed by the Malaysia. So despite of being a number one, okay, in the ranking, okay, Singapore is still taking a proactive step to buffer from food supply disruption by increasing its food production from less than 10% to 30% by the year 2030. The policy is called 30 by 30, which identify new areas such as urban and precision farming through the Internet of Things or IoT as their main strategy. So along with that, okay, the GSFI also rank the countries based on the prevalence of undernourishment. Okay, this indicates the percentage of population that does not meet the 2,100 kilocalorie per day per person as stipulated by the WHO. All right, so now let's look at the innovation, okay, a few innovation that would actually increase, okay, the food security or enhance our food security. Okay, number one is gene editing, a very interesting scientific concepts whereby we use the gene editing tools such as CRISPR-Cas9 or many others like zinc finger nucleus or talent, which solve many crop related problems for growers. Okay, for example, CRISPR-Cas9 is a nucleus enzyme, okay, that can cut DNA at a very specific location, guided by an RNA. So what they do was using these tools to cut out certain bits of DNA, okay, the undesired portion of DNA in order to control traits, okay. So as a result, if we don't want DNA that can cause what we call that enzymatic browning, for example, that reduce the resistance to drought, for example. So we can actually get rid of this DNA. So after the editing, okay, the cell's genetic structure then repairs itself automatically. This will minus the targeted gene, which we do not want in our crops, for example. So as a result, the results are endless, right? For example, we can come up with something like a reduced gluten weight, or browning of mushroom when cut or bruised, or soybean with a lower unhealthy fats, or even Mars, okay, the chocolate, our chocolate brand is behind the effort to come up with a cocoa species that can fight off a virus that is devastating the crop in West Africa. So what is good about this gene editing technology is that the plants, okay, the plants as a result from this technology will not contain a foreign DNA, which if we have this foreign DNA in the crops, okay, for example, genetically modified organism. It doesn't need to go through a very strict regulation, and it may take years of testing, 10 to 15 years. Okay, so with this technology, okay, gene testing, it may probably take only as short as 2 years, okay, to be approved. All right. So however, there is a reservation, okay, from many parts of the world about this gene editing of crops. Okay, for example, EU has come out with one legislation on these gene edited plants. Okay, they classify it into new genomic technique plants, NGT1 or New Genomic Technique Plants 2, which is NGT2. Okay, so basically, if the plant falls into the category of NGT1, that means it doesn't need to go through the strict regulation or a risk assessment like for MGO for GMO. But you have if you carry out ataupun if the gene editing result in more than 20 genetic modification, then the plant should be subjected to the risk assessment, and it will be then classified into the NGT2. So this is one of the what we call that setback, okay, of the gene editing technology of crops, okay, that you guys as a future scientists should also be looking into. Another one is the synthetic biology. Okay, synthetic biology. There are many functions of abscisic acid, or the short form is ABA. Okay, so in the synthetic biology, they discovered the analog for this ABA. Okay, which can be formed into agrochemicals, and then we can spray to all the crops in response to the abiotic stress, for example, drought and heat. So what is this hormone does is that it control, okay, it control the closure or the open of the stoma holes, okay, so that it can retain moisture in the plant cells when the weather gets very, very hot. Now, so another one is we also need to look at the alternative food sources. For example, insects. Okay, insect farming. There is a potential for insect farming. Okay, to keep this into perspective. Okay, there is 2,000 edible insect species consumed in eggs, larvae, pupae, nymph, or some adult forms in tropical countries. So it provides a lot of energy, protein, as well as the amino acids which is required for humans, or high in monounsaturated fatty acids and PUFA, as well as iron and zinc. So Thailand is more advanced in that sense that the country has 2,000 farms which produce around 7,500 tons uh, what we call it insects-based protein per year. Okay, but for Malaysia, okay, we still have a lot of reservation. Okay, when it comes to insects farming. Okay, we only interested in actually um, feed this protein-based insects-based protein to the animal, okay, to the poultry and also aquaculture. For example, Nutrition Technologies India Berhad, which operate in Johor, okay, they have been producing this black soldier fly larvae to make as an animal feed for the poultry and aquaculture industry, but not yet for the human consumption as opposed to Thailand, our neighboring country. Now, what are the challenges in the food in the insects farming? Okay, um, number one is, you know, as I said, there are 2,000 edible insect species. Okay, so we have not yet identified enough species of insects that is edible. When we are talking about food safety, although insects pathogens can be specific to invertebrate, okay, pathogen spreading can be very quick and very rapid through captive population because we normally keep these insects in captivity. So therefore, sanitizing methods needs to be put in place. Also, when we are talking about the food safety aspects of this insect farming, there is a potential allergy to humans as insects are taxonomically closely related to crustacean like shrimp, which is very much known for its potential allergy. And when we are talking about consumer acceptance, okay, insects or insects-based protein is regarded as a primitive food in certain parts of the world and not appealing to the Western consumers. Now, another one is cultured meat, ataupun we can also call it as a lab-grown meat, all right? So by the use of the stem cell technology, so normally the stem cell ini produce what we call that multiply and produce the muscle tissue. So we normally take one portion of these cells, okay, under with a small biopsy under anesthesia, okay. So in animal, so these stem cells creates new muscle tissue when the muscle is injured. So these cells attach on scaffolds and fat and we fed with the nutrients in a bioreactor under controlled condition to multiply into trillion of cells and form myotubes. Okay, so these myotubes will differentiate and form muscle fibers. So these are all done, like I said, under controlled conditions, mimicking the body of the animals. So one this that needs to be emphasized is that it is simply a tissue engineering technology and no genetic modification that is involved. So it is not a GMO product actually. But why is the cultured or lab-grown meat is growing nowadays? Number one, it can reduce land and water usage by almost 99%. And also livestock farming, our conventional way of producing meat contribute almost 14.5% greenhouse emission. So despite of all the benefit it offers, okay, there are challenges, okay, as compared to the traditional livestock farming. Number one is the culture medium for the stem cell is very expensive because when we inoculate these stem cells in a bioreactor, so it needs nutrients, okay, that is provided by this culture medium. So this culture medium is very, very expensive. For example, L52, L15, okay, and also M99. The second one is the texture. Okay, the texture of this cultured meat may not be as compatible as the meat from the livestock. Okay, so this cultured meat is basically processed or minced meat, and the production of a thick piece of meat is not quite there yet until we actually finalize the 3D bio printing. So it also has this element of unnaturalness, inferior taste and texture if we are talking about the consumer acceptability of cultured meat. If you're talking about the legislation of this lab-grown meat or cultured meat, Singapore, in fact, is the first country in the world to approve a cultured meat product for sale by the Singapore Food Agency (SFA). Okay, they start off with this cultured poultry meat. If we look at the other side of the world, okay, the EU countries, cultured meat is legally treated as a novel food, though Italy and Hungary, these are the two countries could possibly ban this cultured meat. However, it gets very controversial within the EU because of the EU policy that they should promote no borderless trade. That means the product has to freely transported into the members country of EU. So also the EU has the reservations about how to label this cultured meat. If you want to produce, for example, a burger or steak or sausage, okay, by using cultured meat, you may not be able to identify your product as it is if you use the cultured meat. The reason is that maybe because the European community is very conservative about what they call as burger. Okay, so it has to be made from the livestock, okay, or steak and sausages. So cultured meat has that issues when it comes to the labeling of these such secondary products. Now, another alternative food sources, microalgae. Okay, microalgae is a photosynthetic microorganism that are able to rapidly generate biomass, okay, from solar energy or carbon dioxide and nutrients in the body of water. For example, spirulina. Okay, it's called superfood because it contains a lot of amino acid or fatty acids, carotenoids, fibers, vitamins, iron, and calcium. But the challenges is that harvesting of this microalgae is a daunting task because we need to remove the culture medium as much as possible. But the small density difference, okay, between the culture medium and the algae, okay, will actually make the harvesting difficult. So eventually we would get a very, very low yield. And when we are talking about the safety of these microalgae, normally we actually put these byproducts of agriculture or natural waste, okay, to give nutrients to these microalgae. So this safety of biocomposites needs to be examined. So synthetic biodegradable needs to be tested is as an approach to actually reduce the risk, okay, of any unknown safety issues when we are talking about microalgae. The third one is bioremediation. Okay, bioremediation is highly sensitive to microalgae is very highly sensitive to certain pollutants which can be toxic. Okay, algae require very specific optimal condition for growth, for example, light, nutrients, or temperature. And harmful algal blooms, or we call it as HAB. This is a toxin producing algae that compete with the microalgae that we want to harvest in the ponds, okay, as a result of the excessive temperature and nutrients. So these blooms or algal blooms needs to also be monitored and discarded during the what we call that maintenance of this microalgae plantation. Um, we also have to look into the photobioreactor. Okay, instead of we cultivate microalgae in an open pond. Okay, photobioreactor is a way to go because of the cost. Okay, the use of less area of land, the scalability. We can just scale it up to whatever level we want. Okay, the light penetration can be 360 degree. That means as long as this photobioreactor has been very well put in place in Europe, okay, in which they actually put it in an aquarium, the microalgae in an aquarium, and then we don't have that much problem in terms of getting light in many different corners or when we are talking about light penetration and distribution. Now, food waste, all right? Okay, so food waste is another area that we should also be looking into. 1.6 billion tons of food is wasted along the chain, okay? And unfortunately, 1.3 billion is edible. All right. So food waste, but we need to distinguish, okay, what is actually food loss uh, as opposed to food waste, right? So food loss normally takes place at the production, post-harvest and processing stage. But food waste refers to what is lost at retail and by consumers. So areas to be explored in managing food waste is packaging. Um, we have this active and smart packaging. Okay, when we are talking about active packaging, that means we incorporate additional components into the packaging to enhance its properties such as permeability to moisture, light, air, or prevention from oxidation, ethylene removal, and so on. For example, silver nanoparticle has been also introduced into the gaps between the polymers to enhance oxygen barrier. But however, there is an issue with the toxicity of these nanoparticles due to a very small size that could penetrate into human cells. Uh, For smart packaging, for example, okay, smart packaging normally have very tiny devices that could tell the physical, chemical, as well as microbiological changes of food in the package. However, more research needs to be carried out to come out with sensors that are secured and resistant to physical handling of these food packages. Another thing is biodegradable food packaging. Okay, uh, the problem with the biodegradable food packaging as opposed to plastics, okay, it has a low tensile strength. Although biodegradable food packaging is known to reduce landfill waste or reduce the methane emission, okay. Um However, the disadvantages such as limited performance, as I said, the low tensile strength needs to be looked into, and also it has a very shorter shelf life due to its sensitivity to moisture. So the issue is the use of food crops for biodegradable packaging can also raise concerns about diverting resource away from the food production. That means when we put so much emphasis on this biodegradable food packaging, what happens is that we tend to forget to actually produce food crops for human consumption, for example. Then it's going to actually raise the food the price of the food items as a result of the intensive effort of this biodegradable food packaging. Now, valorization of agricultural waste, okay, is another way of is another approach, okay, in how we can actually look into the maintaining and enhancing our food security. Biodiesel, for example, okay, um, biodiesel, the palm oil production, okay, can actually produce biodiesel, okay, with the use of this waste cooking oil, okay, and it reacts with methanol in the process of trans-esterification that produce fatty acid, methyl esters, and glycerol. So these fatty acid, methyl esters, we call it as biodiesel. Okay, and glycerol is a byproduct of this biodiesel production that can also be applied in pharmaceutical as well as the cosmetic industry. So what is the Malaysia, where does the Malaysia stands on this biodiesel production? And in fact, not only Malaysia, but other countries in the world. Um, Over the years, okay, we try to actually increase the amount of this biodiesel to be incorporated into our conventional fuel. Okay, like for example, in 2014, we incorporate around 7% of this biodiesel, and then we increase a little bit more in 2019 by 3%. That means 10%, and in the year of 2020, we incorporate almost like 20% of this biodiesel into our conventional fuel. And this 20% incorporation of diesel should be the sweet spot, okay, for the incorporation into the conventional fuel, because if we go even more if we go further than the 20% portion of this biodiesel, so it may not be compatible to the engine or the fuel system of our vehicles. So that is biodiesels. Okay, when we are talking about um, green solvents, okay, green solvents, as you know that if we apply or incorporate green solvents in our food processing, so it's going to actually reduce our solvent residues in food. Okay, then we can actually put a clean label on our food products, which reduce the all these regulatory hassle. Okay, example of the green solvent, for example, ionic liquids or deep eutectic solvent or DES. Okay, so ethyl lactate, for example, which is a combination of lactic acid, glucose, and water, is used, okay, to extract phytochemicals from the agro waste. Okay, so this phytochemical, as you may well know, that give a lot of health benefits, for example, antioxidants, and many more. But with this application of the green solvents, okay, the food ingredient from these phytochemicals, they will not be subjected to a very thorough inspection ataupun a risk assessment because of the absence of organic solvent, which can be hazardous or which can be carcinogenic to human. And when we are talking about single cell protein, okay, single cell protein, what is a single cell protein? Okay, these are the microorganisms, for example, yeast or algae or bacteria, in fact, or fungi, which can yield up to 80% dry weight of protein, okay, which is also rich in amino acid or essential amino acids as well as vitamin. So what they do with this production of single cell protein is that these microorganisms will be fed with agro waste, okay, in a bioreactor, okay, through a bioreactor fermentation. Then they will start multiplying to supply us with high protein, which is called single cell protein. There has been what we call that example, for example, yeast, which can grow on molasses, as well as the bacteria that can be fed with methanol or carbon dioxide gases, okay, to produce more bacteria that would give you that give high result in high yield of single cell protein. Another one is urban farming. One aspect that we also should look into. Okay, Malaysia is one of the most rapidly urbanized countries in Southeast Asia. Okay, we project that urban population will reach almost 80% by sizes in 2026. So urban farming is a way to go. So why is it that important? Because 80% of arable land suitable for agriculture are already being used, okay? And also the productivity per unit area is enhanced, okay, through this vertical farming. Companies in Malaysia, just to name a few, City Farm Malaysia or Babylon Vertical Farms, Urban Farm Tech. So these are companies these are the Malaysian companies who already what we call that start what advocating the vertical farming to as an alternative for the conventional agriculture. But there are challenges with this vertical farming. Number one is the high startup costs, okay, because we need to actually build the buildings, and then we need to actually control the climate system needs to be controlled with all the insulation and sensors. So the high startup costs can be very high, which is which may not be attractive to what we call that people or farmers from the B40, for example. Okay, that is why it is being currently championed by all these big companies. High power consumption, okay, it needs 24 hours a day of lightning. So solar panels could be a solution, but this also will increase the upfront cost. If we are talking about stable crops like rice, okay, can it be planted by this vertical farming? Okay, that is another issue that we need to do some research. Also, root plants, maybe, with the aeroponic system might work, okay, for root plants that supplies most of our carbohydrate, right? So aeroponic system basically is to culture plants using maize instead of liquid solutions. So the roots too is being suspended in the air and misted with water. So it saves a lot of water, okay, by 95% of water consumption. So the plants are more nutritious, so it's going to grow faster. It's probably disease free or pesticide free, but however, it is only limited to certain herbs and fruits, but it may not be there yet for the root plants. So hydroponic vegetables, there is always a perception that hydroponic vegetables are considered as tasteless and watery. Okay, so public awareness, it needs to be there to educate people to prefer more of these kind of vegetables. All right, last but not least, IoT or Internet of Things, okay? IoT or Internet of Things is the physical object that are connected with the internet via sensors, software, and other technologies. And today, 7 billion devices are already connected to the internet, okay, which make the IoT possible for the precision farming. In 2025, okay, it is projected that 22 billion of devices will be connected. Okay, looking at the current situation, only paddy and palm oil plantations are the two sectors that have used this technology in Malaysia. Okay, it's probably the challenges or the problems that we've been encountering. For example, the cost, the initial investment for IoT devices, okay, can be very high, okay, because we need to buy the sensors, we need to buy the network infrastructures, okay. When we are talking about the standardization, okay, the device compatibility, okay, which model that we are using, okay, it needs to be compatible throughout our food production supply. and industry, and also it needs to be industry-wide standard. For data reliability and security, okay, if there is any system failure, that means the whole food supply chain will collapse. Okay, so this one also needs to be um, examined very thoroughly. If there is any system failures or battery issues or even malicious interference, sabotage, and stuff like that, or cyber attacks. Mobility, network coverage is very important. Okay, if we don't have the coverage, so the application of the IoT cannot be widespread. So the coverage stability also one of the factors that need to be considered. And last but not least, environmental conditions, since you are dealing with devices or physical devices. So extreme weather conditions would impact the lifespan of these devices, the lifespan and also the performance of these devices. So that is the challenges or the problems that we need to look into. Okay, if we want to implement the Internet of Things in our food production, and I think as time goes by, there will be more and more technologies. More people will get access to these technology, sensors, and everything, and it may not be impossible, okay, for the Internet of Things to be in place. All right. So with that, I thank you for the opportunity to actually give an overview for this very brief overview on the technological innovation on food security, and I'm open for questions and answers.
Okay, thank you, Dr. Adi, for such an insightful and enlightening presentations. Okay, we'll now open the floor for the Q&A session. May I invite members of the audience to raise their question. Kindly introduce yourself before asking your question. Alternatively, you may type your question in the chat box and I will read it on behalf. Okay, Dr. Adi, we have one question from Dr. Nafisa. The question is, should halal certification standards be updated to address emerging food technologies?
Oh yes, definitely. Because the emerging food technologies like non-thermal technology, and I mean, if you are talking about halal certification, what are the possible areas that could actually jeopardize ataupun compromise the halal Taliban status of the food. Okay, every aspect of food production that contribute to the halalness or should also needs to be re-examined. I think it is not an exemption to actually ignore that the emerging technologies is picking up, and what we call that not only halal certification but many other different certification also should also be looking into this.
Okay, I hope that answers your question, Dr. Nafisa. Dr. Adi, we have one more question from Dr. Nur Mahani. The DES is a powerful solvent to extract bioactive compounds. However, the pH is very acidic, making it challenging to apply in food products. So how do you see to overcome this challenge, Doctor?
I'm not an expert of this green solvent. Maybe doctor could actually share like what just probably if it's the pH is becoming more acidic, then probably we should look into the process on how to actually control the spike of the fluctuate of the pH fluctuate in the processing of the green solvent production. Maybe that could be approach, or we optimize the processing condition in the productions of this green solvent. So the opportunity is wide open.
Okay, thank you so much, Dr. Adi. Okay, thank you to everyone for your questions and active participations. So let us give our speaker another round of virtual applause. Thank you, Dr. Adi.
Thank you very much for inviting me.
Kind reminder to all participants, please complete the feedback form by scanning the QR code shared on the screen. You may also click the link provided in the chat box. So the submission of the form is required for the issuance of your e-certificate. So we truly appreciate your time and feedback. Ladies and gentlemen, before we proceed further, we are pleased to present the corporate videos from our participating universities. These videos will provide a glimpse into their visions, achievements, academic excellence, and contribution to research and innovations. Kindly direct your attention to the screens as we begin with the corporate video presentation from Universiti Putra Malaysia, Universiti Malaysia Terengganu, Universiti Malaysia Sabah, Universiti Teknologi MARA, and Universiti Tun Hussein Malaysia. The video will begin shortly.
Are you passionate about food and its impact on the world? Do you dream of a career where science, innovation, and creativity meet to shape the future of the food industry? At Universiti Malaysia Terengganu, UMT, we invite you to embark on an exciting journey with our Bachelor of Food Science and Food Technology with Honors program. Recognized with a 6-star rating in the 2024 Employer's Choice of University by Talent Bank, our program is a testament to the marketability of our graduates and the trust employers place in them, both in Malaysia and internationally. Our program is led by a team of highly skilled instructors and lecturers who are experts in food technology, research, and development. With strong industry collaborations, you'll learn from the best and stay ahead of the curve in this ever-evolving field. At UMT, you'll have access to well-equipped laboratory facilities that provide the perfect environment for learning and innovation. Here, you'll not only expand your knowledge, but also develop the skills to create groundbreaking food products that meet global demands. Over 4 dynamic years, you'll dive deep into the core of food science, mastering food processing technology, food engineering, quality assurance, food safety, and food legislation. But that's not all. You'll also gain hands-on experience through community projects, industry visits, and competitions, both locally and abroad. Graduates of our program enjoy a wide range of career opportunities across various sectors, including government agencies, multinational food corporations, and entrepreneurial ventures, both at home and around the world. Join us at Universiti Malaysia Terengganu and take the first step towards shaping the future of the food industry.
Welcome to Universiti Malaysia Sabah. Located in the land below the wind, Sabah, Malaysia. UMS is often considered as among the most beautiful campuses in the Southeast Asia, with Mount Kinabalu and the South China Sea as its background. Faculty of Food Science and Nutrition was established in the year 1997, 3 years after the establishment UMS, with 2 initial undergraduate programs. Faculty of Food Science and Nutrition, FSMP, is formerly known as School of Food Science and Nutrition, SSMP. FSMP has entirely operated at its own building, which is located beside Masjid UMS since then. In 2009, SSMP introduced a new program which was a Bachelor of Food Science with Honors, Food Service. In line with the UMS academic transformation, following the 20th anniversary celebration, the name of SSMP was changed to the Faculty of Food Science and Nutrition, FSMP, on the 1st of June 2014. FSMP strives to be the center of innovative academic excellence of international standard in food science and nutrition, provide a world-class teaching curriculum, create a conducive environment for academic staff, and produce quality consultants are one of FSMP missions.
So my name is Chui En, but you can call me Vivian. My course is Food Service and I am in year 2 currently. Food service, you study about food science and technology. At the same time, you also practice culinary training. So it is more or less like a chef wearing a lab coat. Sometimes we would be in the lab studying about nutrition, physical properties of food. Sometimes we will study microbiology. Meanwhile, in the kitchen, we get to study about some Eastern and Western cooking. And then for our food service specific courses, we do also have some accounting classes as well as some food culture classes. More or less, there are things that you need to know when you are in the service industry, where you need to take care of inventory, you have to do purchasing, storaging. Aside from the technical parts, we also have the cooking side, where we do learn cooking, not only from foods in Malaysia, we also cover the food in the eastern region as well as the western region.
My name is Muhammad Dandan bin Farsaudi. The specialty of the field that I'm taking currently right now, which is food science and nutrition, I learn the science and also the miracle behind the food process itself, the safety, the microbiology from the making of the food until the consumer stage. So it also intertwines the benefit of the foods with the health of the consumers that are consuming the food. So basically we are learning about how the food affects our daily life in the society.
Hello, I'm Vivina. So currently I'm a final year nutrition student. The specialty of the field that I'm taking, which is nutrition, is that it focuses on how using food and an active lifestyle to prevent diseases and also help us to improve health. Besides that, it combines the science of food as well as an understanding on the body's nutritional needs. Our program includes and also combines foundational and professional courses which prepare us to be an accredited nutritionist in the future. Nutrition isn't just all about food and an active lifestyle. It does also considers how we understand the client's needs, communicating well, as well as approach their main concerns from a scientific and also an empathetic perspective.
Hello, my name is Elvina Tasasantana Jumat. I'm currently taking field food technology, which we learn the application of scientific and engineering principles, and we apply it during the processing, production, preservation, and also distribution of food product. We ensure that the food product meets the quality and also the law regulation, but importantly, we want to fulfill consumer demands. So, for example, we learn the process designs and equipment designs and how the changes of the food compositions during the processing and also during the storage of the food.
I am Hilary Kwesi Ketemepi from Ghana. The courses they offer, which is food safety, food security, food nutrition, halal, all these programs help contribute significantly to the national goals.
Hello everyone, my name is Jia Jia, a PhD student from China. I choose UMS because of its excellent academic reputation, wide international network, and the super approachable lectures.
The food career industry is important in my opinion, as currently there are a lot of novel food ingredient is being underexploited, and it is the role of us food scientists and technologists to explore and fully utilize the potential of this product to grow the food industry in our future.
As we see, Malaysia faced various challenges during the pandemic, such as disruption in imported goods, labor shortage, and shortage of food supply. So career in agriculture, food supply chain, quality assurance really helps in ensuring a continuous food supply.
I'm really looking forward to more international students joining FSMP and creating a better future together.
In the next 10 years, FSMP are aiming to be the national and world best center for higher education, training, and research in food science and nutrition.
Fakulti Sains Gunaan dan Teknologi UTHM menawarkan 7 program sarjana muda. Sarjana muda Sains Teknologi Makanan dengan kepujian. Program yang diiktiraf oleh IFT ini merangkumi bidang kursus seperti teknologi pemprosesan dan pengawetan makanan, pembangunan produk makanan serta makanan halal dan eksekutif halal. Sarjana muda Sains Analitik Data Komputasi dengan kepujian. Program 2U2I pembelajaran berlandaskan kerja ini merangkumi bidang kursus seperti perlombongan data, penyelidikan operasi dan kecerdasan buatan. Sarjana muda Sains Kimia Industri dengan kepujian. Program 3U1I pembelajaran berlandaskan kerja ini merangkumi bidang kursus petrokimia, minyak dan gas, pendigitalan dalam industri kimia serta proses unit dan operasi industri. Sarjana muda Sains Matematik Teknologi dengan kepujian. Program 3 tahun ini merangkumi bidang kursus kawalan inventory, pengkomputeran peralatan industri dan matematik aktuari. Sarjana muda Sains Statistik Industri dengan kepujian. Program 3 tahun ini merangkumi bidang kursus seperti survei, peramalan dan kawalan kualiti. Sarjana muda Sains Fizik Gunaan dengan kepujian. Program 3 tahun ini merangkumi bidang kursus seperti sains bahan, fotonik dan tenaga diperbaharui. Sarjana muda Sains Kepelbagaian Biologi dan Pemeliharaan dengan kepujian. Program ini merangkumi bidang kursus Kepelbagaian haiwan, serangga dan tumbuhan, tinjauan dan pemantauan kepelbagaian biologi dan etnobiologi. Lulusan program Teknologi Makanan, Fakulti Sains Kegunaan dan Teknologi kini menyandang jawatan pakar penyelidikan, Executive Quality, Teknologis Kawal Selia, dan pensyarah. Graduan program Fizik Gunaan, Fakulti Sains Gunaan dan Teknologi kini telah berjaya menjadi jurutera projek, jurutera proses, eksekutif pemasaran dan pakar produk, dan jurutera operasi. Graduan program Matematik Teknologi, Fakulti Sains Gunaan dan Teknologi telah berjaya menjadi analis operasi perniagaan, pegawai eksekutif, dan pegawai pengurusan kontrak. Lulusan program Statistik Industri, Fakulti Sains Gunaan dan Teknologi kini menyandang jawatan Perunding Penasihat Strategi Teknologi, Pegawai Pengurusan Prestasi Telco, dan pensyarah. Dan menyambung pengajian. Graduan program Kepelbagaian Biologi dan Pemeliharaan, Fakulti Sains Gunaan dan Teknologi kini menyandang jawatan Pegawai Program Kawasan Terkawal Fraser Hill, Pegawai Pematuhan Aerodrom, dan Pegawai Persekitaran. Untuk maklumat lanjut, sila layari fast.uthm.edu.my.
Before we continue with the awarding ceremony, we are privileged to present recorded closing remarks from the Head of Departments and Program Coordinator from our participating university in honor of this meaningful gathering. It is my pleasure to present messages from Associate Professor Dr. Rashida Sukur, Head of Department of Food Science, Faculty of Food Science and Technology, Universiti Putra Malaysia. Associate Professor, Technologist Dr. Nurul Muhammad Sukur, Head of Program, Department of Food Technology, Universiti Malaysia Terengganu. Technologist Dr. Muhammad Azri Awang, Head of Food Technology Program, Faculty of Food Science and Nutrition, Universiti Malaysia Sabah. Dr. Siti Roha Abdul Muttalib, Program Coordinator, Department of Food Science and Technology, Faculty of Applied Sciences, Universiti Teknologi MARA Shah Alam, and also Associate Professor, Technologist Dr. Norazlin binti Abdullah, Department of Technology and Natural Resources, Faculty of Applied Sciences and Technology, Universiti Tun Hussein, Malaysia. Please bear with us for a moment as we resolve a minor technical issue.
Assalamualaikum and a very good evening to all. Deans and Head of Programs from UNT, UMS, UiTM and another newest partner, UTHM. This marks our 4th year of organizing the big event of Food Science and Technology Undergraduate Colloquium, or we call it FOSTUC 2026. And this year, we are delighted that our partner UMS is taking the lead for the organization. When we pitched the idea back in 2023 to UMT, we are excited that they received the invitation with an open arms. After 4th year, we have grown stronger with participations from 5 universities and not just focused on food science and technology, but also expanded to food service and nutrition. To invited speakers, thank you for sharing wonderful insights regarding advancement in food science and technology research. To esteemed supervisors and judges, and most importantly, our brilliant young researchers, thank you for your support and participation. As we come to the closing of FOSTUC 2026, I would like to extend my heartfelt congratulations to all participants. Your hard work, dedication, and sacrifice have been truly inspiring. This competition is not just a showcase of talent, but it is a platform for innovation, collaboration, and pursuit of knowledge that will shape the future. Whether you walk away with an award or not, remember that the true achievement lies in the knowledge gained, connections and friendship made, the passion of research, and always strive for excellence. We are incredibly grateful for unwavering support of the deans, heads of programs, and faculty leadership in supporting FOSTUC 2026. To the organizing committee who has contributed tirelessly and has made this event a huge success, congratulations. We are truly grateful for your invaluable contributions. We hope that this friendship and collaborations since 2023 doesn't stop here and will be continued in many years to come. I would like to end my speech with pantun. Bunga cempaka harum mewangi, tersusun indah di taman desa. Program terlaksana dengan harmoni, semoga bertemu di lain masa. Cahaya mentari menyinar desa, angin berhembus lembut ke taman. Terima kasih semua yang bersama, jalinan ukhuwah terus berkekalan. Thank you, terima kasih, and sampai jumpa lagi.
Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. We are grateful to Allah Subhanahu wa Ta'ala for providing us the opportunity to attend the 4th Food Science and Technology Undergraduate Colloquium 2026. Over the past 2 days, we have been nourished with insightful knowledge and innovative presentations from our final year undergraduate students. The presentations were centered around the theme Advancing Food Security Through Translational Science. I hope that this colloquium has not only provided valuable discussions, but has also contributed to identifying solutions to some of the pressing issues affecting food security. I would like to express my heartfelt gratitude to all the presenters for their hard work and commitment in delivering such remarkable presentations, which we had the privilege of listening to. A special thanks also goes to the panel of judges for their constructive feedback and the organizers from UPM, UMT, UMS, UiTM, and UTHM for their dedication and tireless efforts in making this event possible. Your commitment has ensured the success of this online gathering, allowing us to connect, share, and learn from one another. We hope that this colloquium will continue to become an annual event, fostering continuous collaboration in food research and innovation. To all junior students, especially those from UMT, I hope you have gained valuable knowledge from your seniors' presentations. The time will come where you will undertake your own research, and hopefully you can carry forward the spirits of excellence in the future. Inshallah. Thank you.
Assalamualaikum and a very good day to distinguished guests, keynote speaker, respected jury members, dear undergraduate presenter and participant. As we conclude FOSTUC 2026, I would like to express our sincere appreciation to everyone who contribute to the success of this conference. We would like to thank Universiti Putra Malaysia, Universiti Malaysia Terengganu, Universiti Teknologi MARA, and Universiti on Malaysia for their strong support and collaboration. Our heartfelt thanks also go to the organizing committee for their hard work and dedication. Lastly, we are truly grateful to our keynote speaker for their valuable insight, to our undergraduate presenter for their excellent research, and to the jury committee for their time and professional evaluation. Thank you to all participants for making this conference meaningful and inspiring. And we look forward to welcoming you again at the next FOSTUC. Thank you.
Assalamualaikum and good afternoon. As we conclude the Food Science and Technology Undergraduate Colloquium 2026, FOSTUC 2026, I would like to take a moment to reflect on what we have accomplished together. Over the course of this gathering, we have witnessed not only insightful research and meaningful discussion, but also the passion and potential of the next generation of food scientists. To our participants, students, young researchers, speakers, judges, and lecturers, thank you for sharing your knowledge, ideas, and energy. Your contribution have enriched this platform and strengthened our shared commitment to advancing food science and technology. My deepest appreciation goes to the organizing committees and secretariat from Universiti Malaysia Sabah, Universiti Teknologi MARA, Universiti Putra Malaysia, Universiti Malaysia Terengganu, and Universiti Tun Hussein on Malaysia. Your dedication behind the scenes, careful planning, and spirit of collaboration have made this colloquium a true success. To our students and young researchers, may this experience ignite greater confidence in your abilities. Continue to challenge ideas, seek solutions, and innovate boldly. The future of food security, sustainability, and technological advancement rests in your hands. And to our collaborating universities, let us continue nurturing this partnership, sharing expertise, supporting one another, and building stronger academic ties for the benefit of our communities and our nation. Thank you for your commitment, your collaboration, and your excellence. May this not be a farewell, but a stepping stone towards even greater achievement together.
Assalamualaikum warahmatullahi wabarakatuh, and greetings to everyone. First and foremost, I would like to sincerely thank the organizing committee for inviting UTHM this year. Your invitation gave our students and faculty a wonderful opportunity to share, learn, and collaborate with peers from universities across the country. It is truly an honor to be part of FOSTUC 2026. I would also like to express my sincere appreciation to the entire organizing committee. Your hard work made this event possible. Thank you as well to all participating universities. Your presence shows strong academic collaboration and a shared commitment to advancing food science and technology. Today, we witnessed many presentations, some highly technical, some are very detailed, and some very brief. To all students, you did not just present slides, you presented months of hard work, late nights, repeated experiments, and even a few failed trials. Okay, that is research. Not every formulation works the first time, and not every data point behaves as expected, right? Okay, but every challenge teaches something valuable. And today, what we saw was more than just data. We saw resilience, we saw critical thinking, we saw future innovators in the making. Food science and technology is not only about what happens in the laboratory, It is about what reaches the consumer's table. It is about safety, sustainability, quality, and responsibility. I am proud to say the future of this field looks very promising. To the supervisors and lecturers, thank you for guiding, mentoring, and sometimes asking challenging questions. Those questions are not meant to discourage, they are meant to sharpen minds. Okay, now to the winners, congratulations. Your hard work has been recognized and you truly deserve it. But to those who may not be taking home an award, please remember, not winning does not mean your work is not excellent. Your effort is valuable, your research is still meaningful, and your journey is still progressing. As we conclude FOSTUC 2026, I hope this colloquium becomes more than a graduation requirement. Let it be a stepping stone toward postgraduate studies, industry leadership, or future academic careers. To the students, today is not the end. It is the starting point of your journey. Keep asking questions, keep experimenting, and most importantly, keep improving. Because innovation in food science and technology does not happen overnight. It happens through persistence. Okay, congratulations to all presenters. You have done very well. And once again, thank you to the organizers for inviting UTHM this year. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you to the heads of departments and program coordinator for your inspiring and meaningful remarks. Before we proceed with the award announcements, let us take a moment to watch a highlight video of the program. Ladies and gentlemen, we have now arrived at the moment we have all been waiting for, the announcement of the winners for FOSTUC 2026. For this year's Colloquium, there are two award categories being contested to recognize outstanding research quality, clarity of delivery, scientific contribution, and overall excellence demonstrated throughout the presentation. These categories are social sciences and science and technology. Without further ado, let us proceed with the announcement of the winners. For the social science category, there were 15 participants from 3 universities, and only 3 outstanding recipients were announced as the winner for 3rd place, 2nd place, and 1st place. Are you ready? For the social science category, the 3rd place goes to Siti binti Muhammad Rizali under supervision Dr. Paul Badar from Universiti Malaysia Sabah. Congratulations to Lisa. 2nd place goes to Nur Shazwatul Laila binti Muhammad Jufri under supervision Dr. Aina Zafia binti Abu Bakar from Universiti Putra Malaysia. Congratulations Nur Shazwatul Laila. And the 1st place goes to Miss Joanne under supervision Dr. Abu Rahman from Universiti Malaysia Terengganu. Congratulations to all the winners. So we proceed for the science and technology category. For the science and technology category, there will be 3 outstanding recipients selected from 2 participating universities to be announced as 3rd place, 2nd place, and 1st place. We'll start with Universiti Putra Malaysia. The 3rd place goes to So Pao Ching under supervision Dr. Muhammad Hafiz bin Abu Rahim. Congratulations to the presenter and the supervisor. The 2nd place goes to Lukman Hakim bin Farid under supervision Dr. Nurul Izzah Malik. Congratulations, students and supervisor. And the 1st place goes to Sofia Zulkifli under supervision Dr. Muhammad Sabri Patri. Congratulations to all the winners from Universiti Putra Malaysia. Next, we proceed with Universiti Malaysia Terengganu. The 3rd place goes to Liu Xiu Yan under supervision Assistant Professor Technologies Dr. Noriza Muhammad Salwan. Congratulations to the student and supervisor. 2nd place goes to Li Yu Chan under supervision Dr. Nur Amira Binti Musni. Congratulations to the student and supervisor. And the 1st place goes to Muhammad Absar Ali bin Fazali under supervision Professor Madya Dr. Nur Mahani Muhammad Maidin. Congratulations to all the winners from Universiti Malaysia Terengganu. Next, we will announce the winner from Universiti Malaysia Sabah. The 3rd place goes to Lang Yu Yi under supervision Professor Technologies Dr. Hasmadi Mamad. Congratulations to students and supervisor. 2nd place goes to Neo Ryan Elias under supervision Associate Professor Dr. Wolina Binti Pindi. Congratulations to the students and also supervisor. And the 1st place goes to Neo Ping Ying under supervision Dr. Yanti Morziana Abu Mana. Congratulations to all the winners from Universiti Malaysia Sabah. Next, we proceed with Universiti Teknologi MARA. The 3rd place goes to Nur Ain Maisara binti congratulations to the students and also supervisor. And the first place goes to Noor Farizan binti Muhammad Fauzi under supervision Dr. Soba bin Ahmed. Congratulations to all the winners from Universiti Teknologi MARA. And next, we will announce the winner from the Universiti Tun Hussein on Malaysia. The third place goes to Hajar Nur Atira binti Zamri under supervision Dr. Muhammad Zulhafiz Shafiq bin Zulhilmi Chen. Congratulations to the supervisors and also students. Second place goes to Nur Ain Sofia binti Muhammad Effendi under supervision Professor Madya Dr. Balkis binti Haji Abdul Kalim. Congratulations to the students. And the first place goes to Nur Farhana Hizri Roslan under supervision Professor Technologist Dr. Muhammad Fazli bin Abu Bakar. Congratulations to students and supervisor and to all the winners from Universiti Putra Malaysia. Congratulations to all recipients from all participating universities on your well-deserved achievements. At the moment, we have all universities has finally arrived. The announcement of our grand prize winner for Science and Technology category. Ladies and gentlemen, the grand prize winner of FOSTUC 2026 goes to Tan Ji Man with the project title Development of Bitter Melon Momotika Charantia Flakes as Milk Chocolate Filling under supervision Associate Professor Dr. Nur Hayati binti Hussein. Congratulations to Tan Ji Man on these outstanding achievements. May we invite our grand prize winner, Tan Ji Man? Are you here?
Yes, doctor.
Okay, can you share a few words to your friends?
Okay, that's very unbelievable. Okay, thank you to all doctors and panels, and thanks to my supervisor also for guiding me for the journey of doing final year project. I really didn't expect these prizes, and I was like ready, and I don't want to join these competitions at first. Then my supervisor asking to pujo me to join this. Then I was like, okay, I'll join. Okay, thank you so much for my friends and my doctors. That's all. And then, okay, just do it. That is. Thank you.
All right, thank you so much, Tan Ji Man. I like the words redha. Okay, congratulations to all recipients on your well-deserved achievements. Okay, before we log off, let's take a virtual group photos to remember this meaningful event. May I invite everyone to turn on your cameras and switch to gallery view. Okay, let's fill the screen with smiling faces. Okay, we'll take a few screenshots, so please stay with us for a short while. Okay, right. So on the counts of 3, 2, 1. Okay, smile. All right, great. Okay, let's do that one more time to make sure that we get the perfect shot. Okay, ready again? Okay, 2, 3, 2, 1, smile. All right, thank you, everyone. Okay, nice photo. Okay, so on behalf of the organizing committee, thank you once again to all speakers, lecturers, judges, and participants for making FOSTUC 2026 a meaningful and successful event. We look forward to welcoming you again at FOSTUC 2027 where we aim to achieve even greater milestones together. May I kindly remind everyone to complete the feedback form shared in the chat box. Your feedback is very important to us and will help us improve future programs. Thank you. Assalamualaikum warahmatullahi wabarakatuh and have a pleasant day ahead, everyone. Bye.
Waalaikumsalam. Thank you.
Thank you, doctors.
Terima kasih semua.
Thank you semua.
Terima kasih semua.
Tahniah Jiman.
Thank you, doctor.
Alright.